overlapping items. Piling affords interactive grouping, arrangement, previewing, browsing, and aggregation to reduce the complexity and support comparison of large collections of small multiples.
Nowadays, online services are used for all kinds of activities. Strategies to increase the situational awareness of personal data stored by online services are needed. We present Transparency VIS, a visual, interactive web application. It allows common internet users to explore their personal data exports, which can be requested from online services like Facebook, Google, Instagram, or Twitter. Feel free to try it out online.
Attention mechanisms have greatly improved the performance of many language models, yet with great power comes increased complexity. In this work, we present attention flows, a visualization that let users interpret the language model's decisions and gain insights into the underlying self-attention mechanism. We also support model comparison that helps to fill the gaps between models in different training stages.
Hello and welcome everyone to the third workshop on the curation, critique and conditioning of principle and guideline in visualization, or in a shorter name for it is called VisGuides. Welcome to our workshop. We are the organizer. I'm Alfie. Later on you'll be seeing Alexandra and you'll be seeing Benjamin. This is the third VisGuide workshop, and the last VisGuide workshop was in Berlin 2018, where we had a number of 12 papers presentation, a panel on visualization guidelines, and a keynote by Teresa Marie Ryan on formalizing a colorization guide for VIS. The workshop in 2018 was a success as it provided us with the opportunity to discuss and examine how we collect guidelines and formalize them. Besides the VisGuide workshop, we also have a VisGuide forum that allows us to discuss and debate guidelines as well as to ask questions about any visualization topic. We have used the VisGuide forums as a teaching tool. Feel free to explore our VisGuide forum. In our 2020 VisGuide workshop, we aim to explore the transfer and application of visualization knowledge by looking at two specific application cases through two panel discussion. The first case is how well we are teaching visualization in our visualization classes. Visualization is a highly popular tool that many people want to learn, ranging from student to professional, and is not limited to just academia. Visualization can be taught in a classroom and now is being taught in online setting. In the first case, we will also be looking at how we can support informal learning. In the second case is how we look at how we can apply visualization in emergency setting, or how we call it visualizing in the wild. In this case, we look at how we can apply our skills and knowledge in such situation and how we can express our design knowledge in interdisciplinary collaboration. In this workshop, we also plan to look at our position in society, where we are now and what we can improve on. Another objective of this workshop is to collect the lesson learned by scientists from our community on this transfer knowledge. Oh, sorry, yeah. This workshop is divided into two sessions. We begin our workshop by a keynote from Silvia on guidelines, this workshop is divided challenges and opportunities. This is followed by a panel on teaching visualization guidelines. We then have a break, and then we follow on by our second session, where we have our second keynote by Eser on towards operationalizing the language of data visualization guideline, and this is followed by our second panel on visualization response in a time of pandemic. So to help us with the organization of the workshop, we'll be collecting the question either on Discord as well on this Google Doc, as you could see this short URL that we created here. We also want you to tweet about our workshop and let your friends and colleagues know about the VisGuide workshop. Thank you. I'm passing this next to my colleague, Benjamin, who will introduce our first keynote speaker. Oops.
Hello, everyone. My name is Benjamin. You can see my screen. I'm just going to the presentation mode. Welcome to the workshop from my side. It's exciting to have you all here. I hope you had a good trip. This workshop works online. There's always going to be challenges, but as I said earlier, we are the first workshop in one of the first workshops in VIS, so we can try to blame technique and technology if something is not working properly. I've just had a question in Discord that I would like to pass on to the technician, and he says, can the technician switch off the participants list on the screen? I don't know, I don't see this from my side. I'm just passing this on because I'm not sure the technician sees the Discord channel. So as you have seen, there is a Discord channel where you can ask questions, and there is also the YouTube live channel, which is for the attendees to ask questions. We have been told that the questions that you put into YouTube will automatically appear in our Discord. So we're going to monitor the Discord to see if there are any questions coming up from the audience. And I hope that we don't miss any question by that. Okay. Let me now introduce this first session of the workshop. As Alfie already said, the workshop has two sessions, one that runs from just now until 9:30. Remember, we're in Utah now, so this is Utah time. Europe switched time this night, so I hope everyone is here, or maybe they're going to join us in an hour later. So let me introduce you to this first session, which has a keynote and then a set of panelists. And our keynote speaker is Silvia Miksch, who is a professor at the University of TU Vienna. She's the head of the research division Visual Analytics and the Center for Visual Analytics Science and Technology. She has been papers co-chair for VAS 2010, 2011, and in 2020, and also for Eurovis 2012. So she's one of the core members of this community. Many of you certainly know Silvia, and I was inspired by Silvia as always being orange. So you see the slides are also orange in order to match Silvia's picture here, because I couldn't find any color that is not really going against Silvia's orange. So I would like to introduce Silvia and her keynote. The guideline meets guidance, challenges, and opportunities. And we think it's a really nice opening to this workshop. And thanks, Silvia, for coming, for joining us for this workshop. And over to you. I'm gonna stop my sharing here and see if you can enable yours.
Thank you. I try to share. Do you see my slides now?
Yes,
Great.
we can see everything loud and clearly.
Loud and clearly.
Again, if you have any questions for the keynote, please put them in to the YouTube channel or in Discord, or we also have a document prepared. So if there are too many questions, we're going to revert to the document to see which questions we're going to take first. And sorry for that, over to you again.
Okay, thank you very much for the nice introduction, and thank you for the opportunity to talk about my favorite topic, guidance. Yeah? And the challenge what I have today is I would like to illustrate you guidelines meet guidance, and I want to tell you about the opportunities and challenges. And I have to disappoint Benjamin, my slides are not orange, but thank you for the nice orange introduction. Okay, my motivation or my content, what I want to first tell you is what is guidelines, what are guidance, why do we need them? Then I want to characterize your guidance, the different aspects and processes, and I want to introduce a framework to develop guidance approaches which capture particular characteristics, and then I will end with challenging opportunities and a conclusion. Okay, let's first think about why we need guidance or guidelines. If you imagine we all visual analytics or visualization user are overwhelmed by a lot of different information. Just to consider, we have different kind of visualizations which we need to tackle. We have different kind of algorithms which we need to tackle. And next, we also have different kind of parameters, what we need to specify for the particular algorithms and for the particular visualizations. Now, what should we do? Everybody can't try every options. We need to have some guides to help us to solve this. And how we can solve or support the users are with guidelines or guidance. Let me contextualize what my understanding from guidelines, guidance, and another concept is. For example, we have also guidelines, guidance, and onboarding. If you think about guidelines, guidelines are applied in the developing phase of a visualization or of a visual analytics solution. Guidance aims to support the user while working with a visualization and keep the analyzing loop ongoing and help to find insights and knowledge. Another concept which is often associated with this idea is onboarding. But onboarding helps the user to learn, interpret, and use the applied visualization correctly. This means onboarding is on the beginning. This I will only tackle in this talk guidelines and guidance. I will not tackle onboarding. I just want to contextualize it. Okay, as you already heard in the introduction, there are a lot of different guidelines available, and I can really recommend you to look at this webpage because it's really nicely structured according to different categories where you need guidelines. I will not introduce guidelines in more detail here because I want to bridge the gap to guidance. And my first step is, or my first part of my talk will be, will try to characterize guidelines in visual analysis, visual analytics, or visualization. I use these terms interchangeable, and this is a joint work what I did in my lab together with the people from Rostock, Hans-Jörg Schulz, Christian Tominski, Fraunhofer, Thorsten May, and from the University of Linz, the JKU, Mark Streit. And it was mainly Davide Caneda's PhD, which he defended yesterday successfully. I'm really proud of him that he succeeded his PhD yesterday. Okay, let's start. What is guidance? Guidance, in short, is a computer-assisted process that aims to actively resolve a knowledge gap encountered by users during an interactive visual analytics session. This means guidance is a process which helps the analyst to gain insight in a huge amount of data. And we try to characterize guidance according to different aspects. The first aspect what we are dealing with is, of course, as you have seen here, the knowledge gap. And the knowledge gap can be characterized according to different targets, known or unknown, or different paths, known or unknown. Or it can be supported by different kinds of domains like data, task, visual analytics methods, or users or infrastructure, which kind of environment you have to use. Let's make it a little bit more clear. What is data? For example, you have some kind of networks data, and you don't know which kind of data would be interested in, and therefore guidance can help you to see different kinds of data and connections, like this approach from May et al. 2012. The other thing are tasks. For example, this is an example by Miksch from 2012, where you analyze different kinds of biomedical data, and you know different kinds of tasks, what you see here in this red line down here, and then you don't know which alternative task you have to take off. And this would help you. This is a knowledge gap that you don't know which kind of task you should address, and therefore guidance should support you with this. The other next aspect, what is important, is that you have different kind of input and output. For example, you can have data as input, or domain knowledge as input, or different kind of visualization images, or history, for example, that you observe some behavior of a user and you want to know what's going on or help him to derive the knowledge gap. On the other hand, if you have the input, then you have also some output. And the output is the most important thing, is that you have an answer to the knowledge gap. And the other thing is that you have different kind of visual means, how you can communicate this kind of answer to the analyst. For example, straightforward means to convey the guidance is, for example, highlighting, that you have some analyzing tool and then you highlight different kind of nodes or different kind of data what would be interesting. Another kind of means or visual means is motion. For example, in this red rectangle, there would be some motion to attract, which would be interesting to go further analysis. Or the other idea of visual means to convey guidance are glyphs and forms. For example, we had this example before from May with these networks, and then you use some arcs to recommend you. This would be a data point which could help you for further analysis. Okay, let's think a little bit more what we need for aspects. The next thing is the different kind of degrees of guidance. You can have the simplest one, which is orientation, which highlights some information, or direction, which gives you more hints, or prescribing, which recommend you the next steps. But we will see this a little bit more clearer in the next steps. And we try to formalize this with a framework or a conceptualization. And we started with the well-known visualization model from Van Wyck, where the different boxes describe containers or artifacts, and the circle denotes different kind of function and processes that transfer the input into a particular output. For example, we have here the data, and then we have the processes, visual analytics, transfer it to images, then we use perception and knowledge to the explanation and the different kinds of specification to gain another step. And we use this basic model from Van Wyck to incorporate their guidance. How do we incorporate now guidance? First, we have our guidance, which needs somehow to be connected. And the first thing is that we need to connect guidance to the different input, what we heard before. For example, data, or we use different kind of visual images, or we use different kind of explorations and history, behavior, interaction logs, or we use domain expert knowledge to gain, to help with the guidance, or we use some domains, or we use the specification, different kind of visualizations or algorithmic approaches as an input for our guidance approach. And then we have different kind of outputs. One is a visual cue in the view, or the other one is providing different options. And according to the different steps, we can now define the different degrees of guidance. One is orientation, where it tells you where can I go, which means we use the visual cues to help the users, to inform the users what to do next or what would be an interesting steps to go. The next one is directions. There we use different kind of options or different kind of recommendations about the target or the paths to take to find insights or to help the user. And the most complicated one is prescribing. And prescribing tells you really which kind of steps you should do next. And you can select which one, but it's more on a very controlled way to help the users. Okay. This is our framework, and I just want to give you an example how you can utilize this. My example is that you guide visual exploration of cyclical patterns in time series. The problem here is that you want to identify cycles in time series, but you don't know the cycles. But you could apply different kind of algorithms or statistical methods, but they don't help you. They are not the solution. You need some kind of exploration and visual support to find out what is the appropriate cycle. Now let's instantiate our framework for this. First, we have to detect the knowledge gap. The knowledge gap was also defined about target. Target was unknown. You don't know which parameter to use to find the correct cycle. And the data, what you have is the different time series, and you want to find cycles. The input is data itself or different kind of algorithms. We just selected 2 different algorithms to support us with this guided approach. And then the output is indicating which kind of parameter setting you should use to encode, and we encoded this kind of guidance within the spiral and within the slider to find the appropriate circle. And the degree what we choose is orientation. This is the most simple ones, which helps you to highlight. Let's look how we did this in the sense that we incorporated, as I told you before, in the slider. This means the simple slider is enhanced with the algorithms, the 2 different algorithms we proposed to help you to gain some insights. The first slider is that you can select the slider and you see these ticks, and the ticks help you to find the appropriate one. And you see also on the other side, on the right side, there's the glow that appears and helps you to fine tune. If it's bigger, then you are more far away. If you're closer, it's a little bit more closer and you're more in the right directions. This is now how the systems works. You have here on the left side, here you have the slider and you can explore around. Here you have the detail view, and here you see how the univariate time series is changing according to the different kind of parameter settings. As you imagine this now, guidance is a mixed initiative approach. On the one hand, you have the system, which is here in green, which uses automatic methods to help the user. On the other hand, you have the user who is exploring the data, find the knowledge gap, and find the next steps. And our approach is that it's a mixed initiative, that you have to support the user on the one hand, and then you have to use the system, and you have to use the system to support the user, which is not, it is really an interweaving of both users and systems. Okay, after we have defined this framework and the different aspects, we thought about how can we support guidance designer to come up with a good solution. And this is also for me the bridge to guidelines in the sense that you need some kind of idea how you need to develop it. And there we defined with similar collaboration partners, guide me in analysis, a framework for guidance designer. And the basic idea of this approach was that our guidance framework consists of particular elements. The first one is that we defined some quality criteria, what our guidance framework should fulfill. We called them availability, trustworthy, adaptive, controllable, and non-disruptive. I will explain this a little bit more in detail in next. And then we have the different steps. We had 4 different steps. One is dealing with the analysis goal. The next one is dealing with the knowledge gap, then the guidance and how we do the feedback. This is according to our framework and the different aspects. And then we defined a couple of questions what a designer needs to tackle to come up with a good solution. I will explain you with the same example of the finding appropriate circles, how you can apply our approach. Sorry, I forgot. We also defined for each of the steps risks and threats and countermeasurements, what you need to tackle in case there are some issues coming up. Okay, let's think about first effective guidance. We wanted to design effective guidance. Effective means that in the end, after you have achieved the goals and you have to divide it in different kinds of tasks, the users are satisfied with this. And therefore, they need to meet particular quality criteria. The first quality criteria is availability. Guidance is there for you. It shouldn't disturb you. It should be here when you need it. It should be trustworthy. This means guidance will help you and you can trust guidance in the sense that it gives you the right hint. It should be adaptive. Guidance will adapt to the different situation. I mean, during an analysis process, the different steps are changing and guidance need also to adapt to the new situation, and it should be controllable. The guidance can be tuned if necessary. Therefore, the users can turn it off or on according to the different needs, or it should be adaptive if, for example, you observe that the user has some limitations or is stalled by a process, you need to adapt the guidance or change the different guidance degree. And the last quality criteria is non-disruptive. Non-disruptive means guidance should not annoy you or mislead you. It should support you, but not disrupt you. Okay, this was the quality criteria. And now let's look at the different steps, what I tackled before, what I addressed before, and which kind of questions we were answering and how you could design them during the design process. And I will use the same example of finding the appropriate cycles, what I did before explaining the framework to understand how the different steps are working. The first question is, what are the analysis goals? In our case of this is finding the appropriate cycles in the data. We have time-oriented data and you want to explore them. The second question is, in which analysis phases issues might occur? When will you discover that you need some help? In this case, we were oriented on visual analytics, and here is the typical Daniel Keim process model for visual analytics. And in this case, the most severe part is when you're doing this modeling part and you don't know which kind of parameter you need. You need the correct parameter settings according to the different needs of the different models. Okay, when we look at these two questions, what are the risks or what are the threats? You can underestimate it, you can overestimate it, and you don't understand the analysis goals at all. And the countermeasures, what we can apply is that we work close together with domain experts, that we understand the needs and what they wanted to achieve. The second step is dealing with the knowledge gap. And in the knowledge gap, you first have to answer the question, what knowledge gaps might hinder the analyst from proceeding? What stall the analytic process? In our example of the cycles, finding the appropriate cycles, that the analyst doesn't know about the length of the cycles. The next question is, are analysts aware or unaware of them? Are the patterns known in advance or not known in advance? In our case, they were not known in advance. The fifth question is, how can potential knowledge gaps be identified during the analysis? There we have proposed two different ways, which I will only shortly introduce now. It's called the knowledge gap interface and the knowledge gap interference. The knowledge interface means that the user can actively specify the knowledge gap, and the knowledge interference is that the system is observing a different kind of behavior and transfers what is the knowledge gap what the person is addressing. What are the threats and risks as before? That you underestimate or overestimate the knowledge gap, and the countermeasures what you can apply is that you assign or to define the most prominent knowledge gaps which could be there according to your discussions. You design very adaptive guidance and you let the analysts really guide themselves during this process. The third step in our analysis is the guidance generation. And in the guidance generation, which is the most difficult part, is that what is the question, what degree of guidance is needed, what mechanisms can be employed to switch among different degrees. I told you that we have the 3 different degrees, and according to the need of the users, we maybe need to switch between the different degrees of guidance. In our example of the cycle, finding the appropriate cycles, we used orientation, and we used, as explained before, this slider to help you to find the appropriate parameter settings of the cycles, and we color code according, the darker the color, the more appropriate the parameter would be. The next question in guidance generation is, what is the input? Which kind of data do we have available? If you remember the different aspects of our guidance framework, we had different input data, domain knowledge, visualization images, or user knowledge, expert knowledge, or history, the behavior. In this example, it was data. The third step is that in the next question is what algorithms or procedures are needed to generate the guidance. In this case, we selected 2 different kinds of algorithms. And the next question is, what are the appropriate means to communicate the guidance? In our case, we used a slider, which indicated the first step, and then a details on demand, which helps you to fine-tune it. And the last question is, when should the guidance be provided? In the sense, when you see moments where the user really needs some support, or when you see some observation according to the cycles and their interactions. The threats and risks is that you introduce some biases, that you recommend some wrong degree, or you have the wrong timing, that you select to provide guidance, but you don't know if this is the correct, but it is not the correct time to provide guidance. And countermeasures are collaborative with end users, allowing to control the guidance and look for particular decision moments. Okay, then the last steps is guidance feedback. This means how can the system derive guidance from the analysis actions. You can give direct feedback or indirect feedback, and what are the directions of the analyst's feedback. Future, this means forward, looking what's going on. Past, looking in the history, and you should always use it with positive and negative one. The risk is this, to provided guidance cannot be controlled by the users, and the countermeasures is that you should really balance this between restricting and guiding the analysts. Okay, this was the overall idea about having quality criteria, these 5 quality criteria, and the risk, threats, and countermeasures, and these 4 different steps, but you don't do them sequentially. This is an interactive design. You should really interact and use them in an interactive way. We have applied this framework for different kinds of examples. What I cannot introduce here, but I can illustrate you or tell you that it's applicable for different kind of application scenarios, and the 12 different questions are applied. For example, we did it for fraud detection as well. Okay, according to the timing, it's now to tell you about the challenges or what we can achieve or what we have achieved or what is open for further research. One is the assumption that we have a knowledge gap, yeah? But detecting the knowledge gap is not that easy. You can do it actively, that the user can tell you where is knowledge gap, or you can interfere it. Finding the appropriate guidance degree is also not easy, and you also need to switch between the different guidance degree that you really support the optimized or the best solutions. The next step is timing, when to do guidance, when to stop guidance. The next one is the guidance process. It's still this a little bit of black box, and you don't know to do it. The next open questions is also that we need an explicit model about the user, about the data, and about the task, and different kinds of biases to have a better guidance process. You need to evaluate the effectiveness of the guidance. And last but not least, you have to have a comprehensive guidance in visual analytics to really support the whole process, because currently it's the guidance in the literature tackles only subcomponents. And my last point, it's bridge to this workshop, is I think we also need some guidelines for guidance, because it's not really quite clear. Our work is the first step, but we really need to bridge the theory and the practice. In conclusion, what I try to show you, or what I try to present you, is on the one hand, I showed you the guidance framework, what we where we extended the Van Wyck model. And the other one, as I illustrated to you, the different kind of our guidance, our framework to help designers according to the different criteria. Okay, I have to thank a lot of people who contributed to this, in particular, Davide Kineda, who defended his PhD yesterday, and also our funding agencies. And thank you very much. I'm a little bit over time, I'm sorry. 1 minute according to my timing. But it's a little bit strange to talk to your laptop.
Thanks, Silvia. We all are getting used to this, talking to our laptop. Thanks so much for your keynote. There is a small clapping icon. I don't know if this is the same thing in the Discord channel, but we're all clapping. So we have a bit of time for questions. I think we also started late, so I'm not sure you really went so much over. Are there any specific questions from, oh, here is an awesome talk comment in the Discord channel. I don't know, Silvia, if you're observing the Discord channel, but
I didn't observe the Discord channel, honestly speaking. I have two screens here, but I can't observe everything.
So I'm calling for any questions from the audience. Of course, put them in the Discord channel, put them in the YouTube, and we hopefully getting all the questions from YouTube into our Discord, but also questions from the panelists and from the other people on the talk right now. Feel free to raise your hand. Are you having a raise your hand button? Apparently, but there is one question from Jonathan. Jonathan, do you just want to speak up, given that you're on the talk?
Just to say, could you say a little bit more about your understanding of the difference between guidelines and guidance? You
know, what I understand is guidelines help you doing the design of the visualization, the interactions, and the analysis. And the guidance is during the analysis process, when you analyze the data and you don't know all the different tasks in advance. Does this answer?
Sorry, you're wanting a response. I don't know. I always think that maybe one is the item that you're doing and one is the process. Is that what you're trying to get at?
Yeah, exactly. Guidance is the process, and guidelines give you the particular points what you should do. Yeah? And
Okay.
for me, these two communities need or the two approaches need somehow to intervene or complement each other. Yeah? Because to have a good guidance process, you have to have good guidelines how to design your guidance process. Yeah? They are not really separated in my point of view. Yeah?
Yeah, no, I agree with that. I thought you were separating them out somewhat. So I was trying to tease out what you were really meaning there.
No, I tried it at the beginning, yeah, that I see them differently. Yeah. And in the end, I try to bridge that we need guidelines to design better guidance processes.
Yes. Okay. Thanks.
I'm seeing another question on the Discord channel, actually. And since the person is not on the call, I will just read it out. I think that including guidance, so the question comes from Shivam Agarwal. I think that including guidance in VA systems will become more prominent. Question. Constructing, selecting guidance algorithm needs a mix of both VIS. Can you hear me?
Mm-hmm.
No, I'm out. No, I'm back. Okay. So the question that Shivam is asking is constructing/selecting guidance algorithm needs a mix of both VIS and domain expertise. Can you please talk how to choose the appropriate techniques/algorithms for providing guidance?
Mm-hmm. I mean, I totally agree.
Maybe I just...
What? I totally
Sorry,
agree.
go ahead.
I totally agree. You need background knowledge. You need the knowledge of domain experts. And to select the appropriate techniques and algorithms, our aspect is that we are considering which kind of data we have available, which kind of data types, which kind of users we want to support, and the most important stuff is which kind of tasks you want to tackle. And according to these three components, we try to find the appropriate guidance process to support the analyst.
Shivam, I hope this is answering your question. I know the communication is a bit laggy, I guess, between YouTube and here. But if you have any more questions, yes, good, that answered the question. We just got the okay here.
Thank you.
And Jonathan agree with Shivam. I have another quick question, but I think we want to stick to the protocol also because the talk is recorded. So unfortunately, we're going to move on. If you have any more questions for Silvia, put them in the Discord. We will forward them to Silvia, and then you could catch up offline about any questions. So Silvia, I will definitely have another question for you. Thanks again for coming.
Thank you.
I hope you enjoy the coffee and the cookies in the hallway. And I'm moving back to my screen here. Not as bumpy as we thought. Okay. So thanks again, Silvia, for this opening the box. And actually, I really like that you had that you closed with this. Oh, we need guidance. No, we need guidelines for guidance. And actually, I think we need also guidance for guidelines. But let me introduce this first panel, which is related to a lot of things that you said, because I think there's a lot of uncertainty around guidelines, how to use their guidelines. So Silvia's talk was about a technical application, so to say, of guidelines on guidance in systems. And we want to now talk a little bit about the human in all this guideline, guidance, framework, so to say. So as Alfie said in the beginning of this workshop, is that we're trying to focus on two specific topics in this workshop, and one of this is teaching and learning visualizations, because it's strongly related to guidelines for many reasons. Because one of the main reasons is that we use guidelines in teaching and education, among many other things. Because visualization is becoming a public topic. It's becoming more widely known, not least due to the current pandemic situation, I guess, that we're in. More people are confronted with visualization. There are more and more teachers and courses out there. We're teaching visualization courses. My courses are full. I'm asked to teach more and more courses in this topic. And we have even on the panel some people who teach 3.5 courses this year already. I come again back to this later. So many academics teach, in fact, visualization. That's what I can talk about at least. But not only academics, there are a lot of courses outside university from freelancers or from other professionals who offer courses from The Guardian, for example, Andy Kirk, and so on and so on. So teaching is not just academic, but it's wider than that, of course. And the different resources right now and teaching and so on and different styles. So the one thing that we almost know best is the classroom teaching. But if you think for informal learning, and especially if people don't have access to courses, then how can we deliver guidance or the guidelines, or at least provide resources for those people wanting to learn? And what we're missing, of course, is methods and activities and so on to help everyone teaching, because it's such a broad topic, as I think. Now, there is more about this to say. There is another workshop tomorrow at the same time as today. Now that everyone has their, in Europe at least, knows the right time, so it's going to be exactly the time as tomorrow. On data VIS activities, which is about teaching and visualization. It's going to be a workshop as long as this one, and I strongly invite you to come to this one. I'm just seeing that my connection. So the goal of this panel is to reflect on teaching visualization. We have invited 5 fantastic panelists who want to discuss teaching methods, the role of guidelines in teaching, of course, what activities are we using to teach people or to support learning. And this is where I think we also need to think about guidance for guidelines in a sense. And of course, challenges and so on and so on. Questions again during this panel, you can put them into Discord, or you can put this into this Google Sheet, which is going to shown on the slide as we go along with the panel. So don't worry for now. Okay, let me introduce our 5 fantastic panelists. It's quite a challenging task to choose just 5 people out of this wonderful sort of visualization community, academic and non-academic. So we had a hard time, and we're sorry for everyone we could not really divide here. We tried to balance different things in choosing persons for this panel. Different aspects. Introduce these 5 panelists to you, and each of these panelists will be asked after I read or introduce each panelist through a short bio. We would ask the panelists to provide us with a short position statement in relation to the topic, and then we're going to open the floor to everyone in the Discord, YouTube, and of course on the call here. So don't be afraid, just drop in your questions. We're going to take them and read them out as we go along. Our first panelist is, and I ordered them alphabetically, so there's no meaning in the order except for the last name. No, last name alphabetical order. So our first panelist is Professor Sheelagh Carpendale, who is now a professor at Simon Fraser University and a research chair in information visualization at the School of Computing at Simon Fraser University. She has a background in computer science and visual arts. She leads also the innovation in visualization InnoVis research group in Calgary, as many of you know. But then now Sheelagh moved to Simon Fraser, where she heads the newly established Interactive Experiences Lab, short IX Lab. She has been introduced into both the IEEE Visualization Academy and the ICM Chi Academy, and has received many awards, including the IEEE Career Award. So congratulations to all these awards. I'm not going to read out all these awards now in order, being conscious of time. But you got, among others, 2 Best Supervision Awards, which I find quite a nice type of award actually to give out. And congratulations again for this award, because it's entirely strongly related to what we are discussing today. And in Sheelagh's work, she has started to work on many innovative approaches to visualization and interaction, but also for teaching. Some of the examples you can see on the slides, to teaching visualization to all sorts of audience using tokenizations, using sketching, as she's also one of the co-authors of this book, Sketching the User Experience. So I don't want to lose more time on this. I want to hand over the microphone to Sheelagh to read out her position statement. And hello again, Sheelagh. Thanks for joining us on this panel. And I hope that the microphone switch will work properly.
Can people hear me?
Yes, we can hear you.
Yes, okay. So I don't know how, well, I will sort of follow my position statement. I definitely want to start in that this whole experience is a process of lifelong learning, and this last year has definitely driven that home. I think, I guess one of the things that I wanted to say is that, you know, that I've had several different points where I've actually thought, oh, I was starting to get a handle on teaching and how I wanted to teach. And then this year has changed everything. And I'm finding that, you know, all kinds of things that I think will translate don't seem to. And then I did find that some do. So online is very different. And part of that is because, you know, philosophically, I have, you know, I really do think, you know, as we learn from Piaget, that we learn best by active doing. So then the question is, how can you have active doing when somebody is just starting, and how does that work? And I use the whole notion of proximal learning or scaffolding, which has really, that's the thing that has been very hard to figure out how to translate into online, because it has to do a lot with the subtle exchanges that happen peer-to-peer and with being there. That's why it's actually called proximal learning, right? And that's been hard to do and hard to figure out how to reestablish. But the other thing that I wanted to say, I think almost the most important thing for me to say in this panel and this workshop on guidelines is that guidelines are sort of relatively new. I think they sort of started appearing in HCI in the mid-late 90s, and they're fading a little now, and I think appropriately. And they're zooming up to the fore in VIS, and that in the design world, and it's interesting because in the 90s, when I first started looking for design texts, I could find this kind of statement, and some of them actually made it like very strongly, like say that, you know, you are foolish not to learn the guidelines of your discipline, but you're even sillier if you follow them. And we don't have the second part in our community. And I think it is actually really important that guidelines are really useful in that, and they have a kind of built into them a way of thinking. So people who go through a particular process often enough, or a group who goes through it often enough, develops a set of guidelines, which they then like distribute to other people. And they're very useful. I think it is good to learn other people's voices, but you have to remember it's not your own voice, and that guidelines will take you to decent. And decent is a very good aim when you're starting and you're a novice, but it is not really the end goal. And the other thing that I wanted to talk about, and I actually brought here, like, I don't know, see if I can, oh, I can't show them because I've got, but I don't know how many, there's a difference between the notion of guidelines, and I have one, this is from the design world. I don't know if any of you know Chip Kidd, but if we have a bit of time, and I'm not going to read it right now because I think we're short on time, but there was one of his guidelines, and I thought the strength of the words and the way they talk about it and the way they leave things like completely open within a guideline might be interesting. So Benjamin and crew, if you want later, I can read this, but not now because I think we'll run out of time. And the other is the notion of cards. And cards are something that we are not using so much in VIS yet, and I think we should explore further. And they are like the pack that I have in my hand is from Diehl. They have 51 cards, and they're more like triggers. They're not telling you what to do. They're more like giving you a wider universe to pick ideas from. And anyway, it's a different approach of guidance than a list of guidelines. And so I think that's what I wanted to say. Thanks.
Thanks, Sheelagh. And there's more time to talk more. Thanks for the pointer to reading out examples later. We have our next panelist, our second panelist, Arzu Coltekin. I hope I pronounced his name correctly. Arzu, are you on the call now? Ah, you are there. I can see.
I am here. I hope the microphone also works. Hi.
Welcome on board, Arzu. Arzu is a professor in human computer. Works perfectly. Arzu is a professor for human computer interaction and extended reality and the Institute of Interactive Technologies at the University of Applied Sciences and Arts in northwestern Switzerland. Her research is focusing on geospatial visualizations and three-dimensional visualization. She's also affiliated with Harvard's Seamless Astronomy Lab. Arzu has been, as I found on the website, teaching 3.5 courses this year in visualization. That's a great university that has so many courses. She's having a lot of experience in teaching, and in fact, as I think she wants to show us now, is also providing a cheat sheet for visualization design on her 10Q Viz website. Thanks again, Arzu, for joining the panel, and over to you.
Thanks, Benjamin. Is that okay to share my screen?
We cannot hear you now. We could hear you. Yes, you should be able to do so. I will stop my one. We should have permissions to share everyone's screens.
I think Arzu's microphone.
It's loading.
We don't hear her. I'm sorry, I don't hear her.
Yeah. Arzu, we don't hear you. But her microphone shows on in Zoom. Arzu, we don't hear you.
Okay, great. Is it working now?
Now it's working, yes.
Okay, it was somehow hijacked by somebody else's, some other microphone. Is it also fine with my screen at the moment?
Yes.
Okay, perfect. Thank you, and sorry for the glitch to begin. As Benjamin mentioned, I'm teaching a number of classes in visualization. For the first year, we do a fundamentals of visualization. Second semester, interactive visualization. Then we build to visual analytics, and there's an information visualization. There's 2 lines of teaching. One is main computer science, the other is data science. And in data science visualization, we find it to be an important topic. In this particular line of teaching, in data science, we have been experimenting with kind of fully bottom-up project-based learning. So we give them challenges and describe projects. Sometimes I also borrow from actually the challenges that are published on, for example, VAST. And then we give them a fully annotated media library. So your books and sometimes your slides or YouTube videos. And then we put them on the task, and then we stand by for their questions. So basically no frontal lectures. And it's been interesting. It's very experimental. I think that they work actually twice harder than normal students. But I think what they learn, it retains a little bit longer. So I think they really learn this way. But I'm a bit conflicted about the balance between what we actually provide them in terms of our expertise and how to do this frontal lecture versus hands-on experiences. So this is one of the things that I would like to maybe mention, because often I think we don't always have recipes in visualization. The answer is often, when somebody approaches you and asks, how do I do this? It depends. It depends on a number of things. And I often share a framework that I published in a cartography conference recently, that it depends on technology that you're trying to use, whether it's the display type or whether certain design elements would matter. Maybe HCI, you have to consider interaction design, or maybe you have to think about computational performance. So another dimension would be, it depends who your audience is. It could be they have certain cognitive and perceptual abilities, maybe some limitations in these abilities. So you have to perhaps personalize or customize how you're doing the visualization. So I also talk to them about context or task, or what is it that you're trying to achieve with the visualization. So there's a lot of factors. I'm not going to go through them because we only have 5 minutes, but just wanted to say that, we considered all kinds of details. Now, the second part, I do that also with my students, but I feel like we should get the word out to other scientists, our colleagues, because in a recent study, we looked at a rainbow color scheme, and to see whether we have to still study the rainbows, we looked whether it's still been, being used commonly. And this was based on planetary science and remote sensing journals. And it goes up to like 70% of the quantitative visualizations that people still use rainbow. I think it's because it is the software default. And it feels like we need to get the word out to our colleagues other than those who come to the visualization conferences. I think that visualization community by now understands the limitations. But even here with the rainbow, the answer is it depends. It's not a blanket binary yes or no. It's true for pie charts and bar charts and all that. I think many of you are quite aware of this. So to be able to do this second part with the outreach of to our colleagues, Alyssa Goodman, actually mostly our conversation started this initiative. I would have to say that it's actually her idea. Hi Alyssa, if you're in the audience. So we started this 10qviz.org. It's a participatory place. We tried to come up with like 10 leading questions. Who is your audience? Is your goal to explore things or explain things? Is it that you have to show categories? Is it that you have to show recognize patterns? So instead of giving them answers, we tried to formulate questions that they themselves would have to reflect. And then we would, give them some examples why this question might matter and annotated pictures. Everybody can contribute. So this is the 2 lines of arguments I wanted to sort of like present as a position. Now I'm going to stop sharing my screen. By the way, the VIS, I know that it's with Z and some of you are allergic to that. We just had to pick something, and at that time it made sense because it's visualization, but I know that some people actually react badly to the Z. Okay, so that's the sidetrack. Thank you very much for your attention. I hope that we can discuss a little bit how to balance between these top-down and bottom-up approaches when we're talking about visualization. I hope the microphone is still working. I think I'm going to stop here, Benjamin.
It's always working. Thank you very much. And I don't know there's any guidance on using a Z or an S. It would be nice to have some. Thanks, Arzu, and thanks for joining the panel again. Here, we go on. Our third panelist is Robert Laramee from the University of Nottingham, where he is an associate professor right now. He's covering a broad spectrum of work in scientific visualization, InfoVis, visual analytics. And Rob has recently made his entire visualization course available on YouTube. So I should have put the link here. I probably should do that in future. Welcome and on the panel, Rob, and over to you to your position statement.
Can everybody hear me?
Yes.
Great. I'd like to just start off by thanking you, Benjamin, and the other organizers of the VisGuides workshop. Thanks for inviting me here and to participate. I actually remember, I don't know why I remember this, but I remember my very first conversation about visualization guidelines. My very first conversation about visualization guidelines was a long time ago. It was probably like, I don't even remember exactly when it was. It was more than 10 years ago, though, and it was with Colin Ware, Professor Colin Ware. So Colin was talking about his first information visualization book, and he was telling me about how he was working on his second edition. And I asked him, you know, what are the differences between the first and the second edition? And he said, well, one of the pieces of feedback he got on his first edition was that readers wanted guidelines. So the first edition of the book contains no visualization guidelines. I think you'll see in further editions, you'll see lots of visualization guidelines. And for some reason, I still remember this conversation, even though it was more than 10 years ago, I'm sure. And I remember my second conversation about visualization guidelines too, and that was with Min Chen. So Min Chen was asking me one day if I know about visualization guidelines and what visualization guidelines that I use in my lectures. And I had not really thought very much about it at the time. And I was thinking about my own class, and I'm like, well, actually my own class does not have very many visualization guidelines in it. My class has a little bit more algorithmic material, and I was like, that's funny, because my class has a lot of algorithmic material which are not explicit guidelines actually. And then I learned about VisGuides.org through Alex, Diehl, and Min Chen. And we started using that as a teaching tool, actually. So it's actually built into the data visualization course we teach. And when I go through my slides now, I also realize that I have a lot of implicit guidelines. So the word guideline is not mentioned, but actually what I'm presenting on the screen or in a slide is often some guideline in some way, shape, or form. And so now when I update my slides, I'm having this guidelines lens applied, and I'm actually writing the word guideline to make some of them explicit. But like Arzu was saying, I think that writing guidelines for visualization is very challenging because it depends on the context. It's very hard to think of a guideline that doesn't come with a lot of constraints. For example, what is the user goal? What is the goal of what you're doing? Or what is the user task? So the guidelines depend on user goals and user tasks and what you're trying to achieve, the background of the user, and so on. It could be presentation, it could be analysis, it could be exploration. So I find it very challenging to think of generic guidelines that really apply independent of contexts. And one kind of classic example is animation. Right? There's not really a consensus on whether animation is good. And the answer is really, well, it depends on the task. What is the task, or what is the goal of the visual design that you're trying to develop? And I think the same is true in real life. I think it's hard to think of guidelines that apply to real life. It's the challenge is that life is very complicated. So it's hard to think of black and white guidelines that just apply across all contexts and across the board. The only real life guideline I could think of that applies across the board is like, look both ways before you cross the street. But there aren't many guidelines that you can apply that really span all different contexts. Anyways, that's basically all I had to say for my position statement. I'm really looking forward to this discussion and all the things I can learn from it.
Thanks, Robert. We're having our fourth panelist, Padilla from the University of Merced, where she's an assistant professor right now. She has a, oh, I'm dropping out again. Can you hear me? I was just restarting. We have Padilla on the panel as well, who is an assistant professor at UC Merced with a background in cognitive sciences and an MFA in design. She researches and studies uncertainty and right now in COVID data. She's also advocating for minoritized groups in STEM and is part of the VIS Diversity Committee. Lace has been interviewed by the DataVis community about the DataVis Society, sorry, for about her teaching as part of a larger panel with Isabel Morelos, Jessica Hallman, Alberto Cairo, and Nicholas Almquist and Steve Franconeri. So you can see how hard it is to pick people from this channel for this panel. So in her courses, she's focusing on problem-solving skills and using visualization as a tool to solve real-world problems. Thanks for joining this panel, and over to you, Lace.
Great, thank you so much for having me. I'm very honored to be included as a member of this group. I'm a new assistant professor. This is my second year, so I'm also new to teaching. But for that reason and my background, I have a slightly different perspective. I am a cognitive scientist. That's what my PhD is in. And so I think about guidelines in terms of theories, which is a slightly different perspective. And the theories that I teach in my courses have to do with how the mind processes visual information. So I think it was really interesting, the discussion about the pros and cons of guidelines and how guidelines can't be ubiquitous across all conditions because there's so much context. The types of guidelines that I find most helpful and interesting to teach are based on the visual system and how our eye processes information, and how our brain processes information. And one thing that is pretty consistent across our human species is that we have the same hardware, some very similar properties, different, contexts for how our expertise has influenced what we're doing, but we do have some similar things, which is why I find it very interesting to bring a cognitive science perspective. And what you're seeing in the bottom, that model, that process model there, is a model that we propose that describes a visualization decision-making pipeline. And it includes the full array of cognitive science that describes how we make decisions, how prior knowledge influences those decisions, how different things can be harder to process than others. So I like to use these types of frameworks to summarize large bodies of cognitive science and psychological research to help students understand why they would want to make a choice of one visualization technique over another. And the way that I frame that is the class that I currently teach is a graduate level course called Global Good Studio. And the objective of the course is to solve large scale global problems like COVID-19 miscommunication, wildfire visualization in California and other places. And what we do on the first day of class is I say, I want everyone to break up into groups and find the most important problem facing the world today. And we're going to try to solve it with visualization. And then we work backwards, trying to develop the visualization techniques they need to solve those problems. And we do that by sort of thinking how people are processing information and so forth. That's kind of the main objective here. And so it takes the form a lot of uncertainty visualization, which is what I study. And a lot of the problems that students are really interested right now in my courses has to do with conveying uncertainty. So we do lots of discussions about that. That's really my perspective, a little bit shorter than everyone else's. But I think it's a more human-centered approach. And then we work backwards from these large scale problems. And I forgot to mention this, we do, for the second part of the class, involve industry collaborators from University Research Association. We bring them in and they give us real world problems. And we also have industry partners in Silicon Valley that come in and give us their problems to try to solve as well. I'm very, very much looking forward to this discussion. Thank you.
Thank you, Lace. And our last panelist, not last, but number 5, is Jonathan Roberts, who is a professor in visualization at the School of Computer Science and Electric
engineering at the Bangor University in Wales, where he's leading the research group on visualization modeling and computer graphics. In his work, he's designing and developing interactive visualization solutions. And Jonathan, I'm always having these issues with the UK names. It's tricky for someone not from the UK. So Jonathan has developed this 5 design sheets methodology, where he also published a book about it, which is called 5 Design Sheets, Creative Design and Sketching for Computing and Visualization, which is something to help students here in the center of the slides to develop visualization designs. And he has also, as he told us in the email, he created resources for learning processing through colorful rainbows. So we're all looking forward to learn about the colorful rainbows, as we have seen in Arzu's talk already. Thanks again for joining, Jonathan.
Okay, well, thanks very much for having me. Yes, I'm at the School of Computer Science and Electronic Engineering at Bangor University, and I have the privilege of teaching and educating students, and I really enjoy doing the 2 things I do. I teach and I research, and all my research, I guess, is visual, and all my teaching is visual. At the moment, I teach a course to master students in information visualization, one for 3rd-year bachelor courses in computer graphics, and lastly, I also teach a design and sketching course to the creative.
I think you're breaking up.
Am I back?
Yes, you're back.
This is doing visualization conference at your home in the middle of Wales. I think with all my research, I try to help others. And it was about 10 years ago when some of my students said, well, you talk about design and visualization. How do you actually do it? And it sort of got me thinking that there must be a strategy that we can help the students learn to do visualization design. And that's how the 5 design sheets came out. And so you end up with sheets of designs that helps you as a student, or helps you as a developer as well, to think through your different ideas. And also we've sort of taken that further and thought about the larger framework, and we've developed this system called the explanatory visualization framework that helps you think about the sort of the wider aspect of applying the visualization, applying the designs, and getting a visualization implementation back. So I guess you're asking in the panel what sort of my standpoint is. Well, I think we should be developing guides. This is my first point. We should be developing guides, and those guides need to be simple and clear to follow. I think is sort of, we need to help others. Secondly, I feel that we need to use them ourselves. If we don't use them regularly, then who else is going to use them? We have to feel that they will work in our situation. If we can get them to work, then they will work for other situations. And that's what I've been doing. And you end up knocking off all those rough dents and rough bits of your ideas. And finally, I guess going back to, so we've gone full circle now. So Sheelagh at the beginning was talking about this idea that guidelines are great for learners to follow. And I actually think that learners should follow them diligently, but also for experts to break. And I think we do need to understand that they have their place and they can be used for a positive reason, but also we need to know where they don't work and some circumstances they don't work in. So as a challenge to the community is, I think we need to develop guidance, guidelines, and then use them ourselves. Thanks so much.
Thanks, Jonathan. And at this point, I open the stage to the panelists, of course, and the audience for discussion. I'm just conscious of time. As always, this is my job in this workshop, really, that we have about 13 minutes, unfortunately, but because I think then the stream probably stops on YouTube. It probably does prevent us from keep talking into the break, but I don't want to run into everyone's break. Are there questions in the channel to some of our panelists? Otherwise, I open the discussions to the panelists themselves. I think Jonathan made a really nice statement in the end. Maybe Sheelagh wants to respond to that.
I switch on things here. Yes, because I don't want to, we clearly are having some trouble with bandwidth, so I don't want to keep them on. So I don't know if any of you have read Saul and Bill's paper on usability considered harmful some of the time, because it makes a fairly eloquent explanation about how you can take guidelines too far. And I think that Arzu and Silvia were talking about the it depends, right? I mean, and yes, there needs to be a time where, as you get more experience, that you realize you're in a situation where it depends, where things have changed slightly and you must rethink, and that's really important. But, you know, that doesn't mean that there isn't. Yeah, so I completely agree with the statement that it's really good to learn them. It's really good to understand them. And I actually think that the more different people in the community actually talk openly about the guidelines that they work with and that they've developed, the more somebody who is learning will get to explore what is essentially, you know, a visualization voice. Like we can do it a la Jonathan Roberts, you know, like, you know, that yours have actually, permeated the community enough that probably people can try them on for size and see how much they fit them, and what they can gain from them. And I think that this is, it's a way in our distributed community that we can let learners experience kind of multiple apprenticeships, which I think is a nice thing to do. A break is going to happen now? Isn't this 10 minutes early for break?
No. I'm just trying to navigate to the questions document actually, but there, this is technology in the 21st century. We're having. Is anyone wanting to reply to Sheelagh?
You know, I'll just jump in there and say, you know, I think that's why I'm interested in this word theory rather than guidelines, because it opens up the idea that different people can have competing theories and no theory is inherently right. I feel like guidelines is a little strict in that it has some kind of connotation that there's a right way to be doing things and here's the guideline. When, just like Sheelagh pointed out, it's more of a voice that people are proposing. So when I talk to students about it, I like to say theory because that's the language I've been educated in, but I think it would be nice to sort of implicitly suggest, as Sheelagh was saying, that it's a perspective really, and there's different ones, and there can be, you know, you can do direct comparisons between them and see which one works best for you.
Can I chip in there? I think that's a really nice idea of having a theory. Although I think some of the times where I would place those structures in, I actually want the students to do it my way. And I think having a theory sort of perhaps loosens that up. So I think I agree with that. There is a real place for this idea of theory. But I think when I'm teaching my students, I want them to do it in a very specific way, follow these structures, follow this process. I know best as a professor, so I think. So it's yeah. So I think there are places for both of those. I think is what I'm saying.
Can I also jump in here? Actually, I think it might complement. Yeah. So it's kind of on topic, I guess, exactly what we're talking about. I think that perhaps we can talk about some guidelines based on convention versus guidelines based on evidence. And I think that the evidence part is accumulating only now. In the last 10 years or so, there's quite a lot of interest in actually conducting user studies and controlled user studies as well. Of course, every user study that is conducted in a controlled manner will do one variable at a time. And because of this, at some point, we need to do meta-analysis to see exactly what actually emerges as a rule or a law or a theory. I think perhaps it's a little bit early for us to talk about theories as a visualization community. Perhaps some of the things are emerging slowly towards that. And I think I agree that the word guideline sort of sounds like we know exactly what to tell you, where it's kind of misleading, and that's exactly why I think that maybe asking people rather questions than telling them, like rather than rules rather than questions. This is perhaps a little bit of a remedy to still guide them, but without telling them strictly what to do and what not to do. So eventually, I think we will get to that theory law part, but I feel like there's only a few items that are almost there, but we are not quite there to really pin down that this particular thing that we observe actually works under every context for every user, right? So perhaps the questions approach, I will still push that. Yeah.
Yeah. Yes. Can I?
Please, yeah.
So I agree. I think that the problem, one of the big problems in our community is that I really actually think that the challenge of making, and you given a set of data that's numbers and perhaps words, perhaps phrases, a bunch of things like that with possible relationships between them, and then something that is visual and spatial, that is a much bigger challenge than most of us kind of want to let on. This is, I think, one of the grand intellectual challenges you can have to make a really good mapping like that. I mean, and that's why some of the work like Lace is doing is like so important, because, you know, it helps us, but we really need to realize that we are still newbies, really, even those of us who've been around a little bit, and that there's a lot we don't know, and that this is a kind of a grand communicative and creative intellectual challenge. I definitely think I try and invite students into both the challenge and pleasure of that. It is exciting to be doing something that is difficult and to triumph. I also really like to try and talk to my students about trying to give them, it's kind of like, you know, more than one arrow in their quiver, that if they try in a particular way, and like often, as you all know, you'll come up against this is just not working, you need to have something else. You can say, oh, well, let's try using somebody else's ideas and see if we can approach it in that way. And the idea of being free, that the solution will still be findable, even if your first path doesn't work. So, and also, I mean, I think that one of the amazing things is that we're talking more and more about design and talking more and more about guidelines in our community. And there is very little talk about the problems of design fixation, of like thinking that I must go this way. And so I do try, maybe a little early on, to try and talk to my students about not getting fixated. But I think that actually early on is the place to try. I know that in my classes, well, I mean, you know, like in our book, we suggested 10, Jonathan suggests 5. It's like, but the resistance of almost all beginning students of going beyond 1 or 2 is enormous. That like now they don't get to come and walk into my office and say, but this one is great, right? My first one is, I'm really excited about this. But if I can actually get them to do 10, it's nearly always the 7th, 8th, or 9th that they actually get enthralled with. And I know that actually 10 is a limit, that they should do more, right? That it's not, So I do start right from the beginning about saying, like, do the work up front, do more than one design, even if it's yourself you're having discussions with.
No, I agree. It's challenging to get some students to go past one. Their first idea is the best. And I think for me, it's nudging them. It's trying to see that there is worth in other ideas. And usually, as you said, rightly so, I would reflect with that and agree with that, that after they've done 5, 6 and more, they start realizing that actually these are better ideas. And I think that's why I sort of do this sort of carrot and stick, I guess. There is a bit more structure to some of my teaching where you have to sit down and do the 5 design sheet or whatever I'm doing to force them into that way. And then hopefully they will see the benefit for doing it later on in their own design work. But yes, no, it's a challenge, definitely.
So somebody just said on the Discord thing about the IDEO cards. I don't know if you can see them, but there's masses of them. And part of the things you can play games with, dealing them out in different ways and just seeing if one of them will trigger. If you type in IDEO and their design cards, they charge a lot for them, but if you get a set, you probably will use them quite a bit. Anyway, they're available, and it's not, these are not guidelines. These are there's usually a picture and a scenario, a possible scenario, and they're to look at and think, can I use ideas or approaches from this thing to help me in my current problem, right? And I think that part of it is, to me, a design methodology is all about thinking of the universe as your inspiration. And that means that you might be inspired by something that you see on the street as you walk to work, about, the way the tea leaves are in the bottom of your cup, whatever, that might trigger some kind of idea. But thinking of that broad way of looking at where ideas might come from, and that any of these might be useful. I think that Georgia Lupi very nicely said that, one of the things we look at Dear Data, and there is 104 delightful, absolutely, totally original representations. And Georgia said that she will get out a piece of abstract art that she loves, and there might be some little thing in it somewhere that she finds useful in thinking about how to make a new design. And so, I have had a student who has just finished, who has been looking at, I don't know, you probably all know that engineering is enthralled with the idea of biomimicry, of learning from nature, that there are so many wonderful solutions that nature has come up with. And biomimicry is definitely something we can apply to visualization, and biology is so diverse.
We're having a question that is this kind of relating to where the discussion is going, from kind of two related questions, I guess. One from Jan Eretz and one from Fanny Chevalier. The one is, how do you force the students to be creative in a sense? So how do you force them potentially not to use guidelines, I guess? And this is related to what Fanny says, is how do you gracefully teach students without confusing them to not follow guidelines when they're having the right level of expertise? So where do you kind of, those were two questions in the Discord.
Can I jump into one?
Sure.
So in terms of like how not to kind of fixate them into a particular answer, I tried to show them the same data plotted in multiple ways. I mean, there's this famous example of the dinosaur. Maybe it's one of you who's here. I don't remember. So I have also similar examples from my own data. So I would show something in 2 dimensions. The pattern would look exactly the same. Then I would show in 3D, and then you would see some anomaly, or vice versa. So I tried to tell them that, okay, don't buy pie chart bad, bar chart good. Don't buy 3D bad, 2D good. Plot your data in more than one way and look at it from different perspectives. you might get different information. You might also appreciate yourself by experimenting like that, what actually serves a purpose. And then I also tell them that they shouldn't test this only on themselves. So some certain visualization design, if it works for you, I show them also some user studies with eye movements, and then I show them how naive users actually take 10 times longer to find the same information than, for example, an expert user. So this is kind of the instruction I at least try to preach. I don't know how much of it sticks, but there's a tendency, and I think Sara was also saying that at some point in the comments, there's a tendency people, if they hear that in one study, pie charts were shown to be bad, they want to take this as a simple message that pie charts are a no-no, but it's not. Like, usually there is nuance. You know, pie charts can be okay if you are showing part of, oh, this community knows them, but the students try to, or the naive users or new people to this domain, they tend to try to take the clean message and just run with that. And then they get this excited, passionate speeches about, you know, 3D bad, pie chart bad, rainbow bad. But it always depends. So I try to preach in the beginning and especially give them exercises that they can use some data set and plot it in multiple ways, and maybe they see something different, and that might help them try to differentiate early on that these guidelines are rough guidelines and that they have to customize for the context, for the data, for the audience. So that's how I try to approach, but obviously you can reach, I don't know, 30, 40, 50 students at a time. So this is, we need a bit larger outreach, I guess. More TED Talks.
I mean, this isn't about creativity per se, but I have lots of examples that I share with my students where we tested a myriad of different visualization techniques, and the one we thought would be best based on guidelines didn't turn out to be the best because there was some unknown bias that we didn't know about, we just discovered. I study hurricane visualizations, and there's one hurricane cone that has fuzzy or blurry boundaries. And we were all convinced that was going to be the best. And I asked the students to all guess which one they think would be the best. And it's not that one. That's not the one that ended up being the best after empirical studies. So I'd like to illustrate examples of where it's very hard to intuit the exact biases that might arise. So you simply must test things out and show them to people and ask, try to get some type of metric of how people understand that information. That's usually my approach. I sort of show them how their own intuitions can be wrong. So therefore don't go with your first approach.
Yes, actually.
Can I jump in? I use two strategies. One is examples. So try and have upfront examples of previous 5 design sheets and give other students work and examples within data as well. So different visualizations, and not just from the traditional visualization community, but from the design community. And secondly, I try to give the students a VIS task that is their own. So they choose their own data set or have their own resource. That means that they can share their solutions without problems of plagiarism. And I think that's a powerful thing, that they're helping each other. And I think peer support is really important to get alternative ideas.
I think that what Jonathan has just said about peer support, I also do. I mean, I know it's more work for me because there's no comparison kind of stuff. For marking, it's harder when you have everybody do something different. And there are all kinds of problems with that, but there are real benefits about them learning from each other. But I am really finding this peer learning, encouraging the peer learning across a distributed tech network where they don't get to hang out with each other is much more challenging, and that they are really missing the peer-to-peer, like, because the difficulty of actually showing like a little beginning demo, which if you're in the same lab, you'd all be aware of each other's work and what you were doing, and pass by it and have small discussions. And the importance and value of those things is, it's subtle what we're losing, but it's profound.
I have a follow-up question. Has anyone found a good method to sort of simulate that online? I haven't. I'd love to hear if the other panelists have figured out how to do.
I've tried with my group a bunch of different kinds of things using Airtable, using mirror boards, and actually, oddly enough, one of the most successful was just using Google, not actually Google Sheets or anything like that, just having a shared folder that people could do sketches in front of them, snap them with their phone, and drag them in. And that it was better and closer, cruder software, but less in the way. You know, any kind of actually, you know, document, the fact that it was just a folder and that people did it slightly differently worked much better. I actually was the first time this semester where I felt like, maybe that actually worked.
Which brings us into the domain of online learning, I guess. The challenges and possibilities of online learning.
So somebody in Discord says that they use Mural. We tried Mural too, and I might be that. Yeah. Anyway, but I think that somehow or other you need to have some kind of equivalent to where everybody can see what each other is doing and talk to each other, because eliminating peer-to-peer learning is much too big a loss for us to accept.
I find it quite hard to do sketching online. I was wondering if anyone has a good experience.
Well, the only thing technique that we have done is, you know, and I have had resistance to people, like usually I provide sketching materials. I just bring them in. So if they don't have their own, they're just there. And so I've had to have quite like, yes, just go to a corner store and spend $1 or $2, get yourself some colored pencils, and, you know, but yeah, the only thing that we've been able to come up with so far is that you sketch freehand in front of yourself, right? Take a snap and join it onto some virtual whiteboard of some kind. Or you're just, most of them will allow simple drag and drop, so it's not too difficult. But yeah, it's hard. Well, so somebody else has one that I haven't tried, Lucid Spark. Anyway, there are a bunch of them out there. One of them, it depends on your university, because a lot of them require that you become a member, and so lots of universities say you cannot require that your students become members of different types of software that they haven't officially approved yet. I certainly have that trouble. I don't know if other of you do, but yeah, it's difficult. It's difficult, and it's difficult because real interplay between peers is not like, when we do this, we have to be very sequential. Someone talks, right? And real interplay between peers is not so sequential.
Can I yes, I agree with what Sheelagh's saying. You miss out on everyone coming together, chatting in the rooms as you're coming in. I wheel in a big box of pens and paper. They know what they're doing that day when I pick up my big box of pens and paper on a trolley. I think the simple solutions are better. I've tried shared whiteboards. They don't seem to work. I think our internet connection's not fast enough.
Well, maybe. Yeah, I don't know. I know that my best in-class exercise is, you know, with Lego, and I can't ask them to buy enough Lego because that's non-trivial, like into the several hundreds. And I know that actually people sneak into the Lego class who are not part of the class because they like doing it again. You can, you know, in 3 hours of some of these Lego things, you can just see people go from not really getting what the problem is to really getting what the problem is. And the sketching I have somewhat been able to reproduce, in online. They're not great, but the Lego, or the tiles, where they'd have to go out and laser cut their own tiles, I am just floored. I don't know what to do. Yeah.
I think, I mean, the sketching we've done is that everyone sketches themselves, like you're saying, they're going to the dollar or pound store to get the cheap materials, and then they take a photograph or show it up at the screen, and that works okay. I've tried it with the online, the sketching, but people then have to have either a tablet or some input in. It doesn't quite work. Yeah.
I think there's a lot to discuss. I have, of course, tons of questions, and there are tons of questions on the Discord channel. Just again, it's my job to keep this to time, and we're already over. So I want to give everyone 15 minutes break before the next session starts, also in case someone wants to switch workshops. I want to thank all the panelists. I'm tempted to ask around the panelists to finish up with the one sentence of what do you think is, for you personally or in general, the most pressing challenge in teaching data viz, or not just teaching, but also learning. So think broader than just this one, this teaching exercise. We could try to go through very quickly one sentence, and I'm going to stop you if you start a new sentence. We're starting with just on the camera here, Lace.
Oh gosh, okay. I think the hardest problem in data viz is really synthesizing all of the different perspectives and approaches in a way that students are aware of the array of what I would call theories available to them, but different things they can use.
Thanks. Bob is next.
I think the biggest challenge that comes to my mind is answering the question, what are the visualization resources available to me? I get this question a lot, and this is a very challenging one.
Thanks. Next one is Arzu.
Right, so I guess because I'm teaching computer science students, it's hard for me to get them past that it's all about making it pretty. So like they are very focused on aesthetics, and I'm like trying to hammer, this is about design, functional design. You want people to actually process the information correctly, and what you're doing, you have to think about if people actually receive the information that they are trying to receive. It's in essence, it's information processing. So this is one of the bigger challenges. They seem to go back to, you know, pretty pictures. I don't know how to get over that for them.
Sheelagh?
I think I would probably just restate that to learn the balance between knowing and understanding guidelines, to once you've actually found one guideline, keep finding others and not taking any of them too seriously.
And Jonathan?
I think, well, I was going to say volume, but that was, I think there's just so many concepts. I think we need, in a way, quick and easy guidelines to follow, and I think that's where we should try to be. I like the 5 design sheets. It's 5 all the way through. Try to keep it simple in that respect.
Thanks everyone again. I'm really sorry that I have to close this discussion, but again, I want to give everyone a break, and I invite you to tomorrow's VIS activities workshop, where we have more time to discuss teaching and visualization, and hopefully we can then discuss the next steps, how to bring this topic forward. Thanks again everyone for joining. Have a nice break, and see you back in sort of 15 minutes for session number 2 by Alfie. Bye-bye.
Thank you.
Thank you
Bye.
all.
Bye-bye.
Morse complexes have shown a great utility in understanding the topology of complex scientific datasets. The noise in the scalar field, however, can significantly distort the Morse complex topology. Hence, we study the extraction of Morse complexes for ensembles of noisy scalar fields through their uncertainty visualization using our proposed statistical summary maps.
We present a flexible and easy-to-use software infrastructure for interactive rendering of large-scale display walls, either from on-site or from remote cluster. The display service can easily be configured to support a range of typical network and display hardware configurations. The client library provides a straightforward interface for easy integration into CPU and GPU renderers. We also demonstrate this framework for use in deploying low-cost alternatives for display walls.
CarxS is an authoring system which enables rapid creation of zooming-based scatter plot-like visualizations in just tens of lines of JSON. We contribute a declarative grammar for such visualizations, which captures a large design space. By working with multi-node database spatial indexes, CarxS enables interactive browsing of billions of data points. Come listen to our talk to learn more.
Taylor-Coyer flows is a turbulent fluid motion created in the gap between the two rotating cylinders. The traditional reason-based methods are only able to capture the small-scale coherent structure. The detection of the large structure depends on the 2D cross-section, which is not the true configuration. We adapt the feature-level set methods and the density estimation to combine multiple attributes and use them as the filter to separate large and small-scale structure.
Deep learning models have become ubiquitous, but we often lack interpretations for their decisions. We developed a visual analytics system to interpret models that perform multi-class DGA classification. For each layer of the model, we visualize clusters inside its activation data, showing how classes and clusters relate to each other. In addition, we provide a decision tree to explain how these clusters are constructed.
Progressive visual analytics provides intermediate results in the middle of computation to address a long computational delay. However, such intermediate results are uncertain, so findings from these results can turn out to be incorrect for the entire data. In progressive visual analytics with safeguards, we suggest to risk the uncertainty, but we allow humans to leave safeguards every time they risk the uncertainty.
We present an algorithm for raycasting Hermite-spline tubes, which result from letting a sphere trace Hermite splines that define its visual attributes. Since we do not employ tessellation, our method enables smooth curves and transitions of radius and color along the tube. Join us for an in-depth look at the intersection routine that enables raycasting hundreds of thousands of them efficiently in real time, and see what makes them a powerful new tool in the inventory of curve and line data visualization.
Ray tracing techniques can create images of astonishing realism and beauty. In the last years, the performance of those techniques has been increased significantly using dedicated hardware. Who thought that it's also possible to accelerate this? We show how to dramatically accelerate force-directed graph drawing with RT cores, yielding a speed up of 4 to 13x. If you want to know more, please see our talk.
CMed is a visual analytics framework for exploring medical image data annotations acquired from crowdsourcing. CMed can be used to visualize, classify, and filter crowdsourced clinical data based on a number of different metrics such as detection rate, logged events, and clustering of the annotations. CMed provides several interactive linked visualization components to analyze the crowd annotation results for a particular video and the associated workers.
As commonly known, dimensionality reduction techniques and their interpretations are complex, biased, and uncertain. In drug design, this highly complicates the search for similar and new chemical compounds. To overcome this issue, Canva brings comparison of different molecular descriptors and properties into one tool, featuring planar, 3D, and table views for evaluating the trustworthiness of high-dimensional data projection.
We present VisGuides, a tool for visualizing hypergraphs where edges can connect any number of nodes. VisGuides is the first technique to display hyperedges with no overlap or crossing. Vertices are represented as rows, time periods flow from left to right, and groups can be shown on the left. We designed the layout for readability. VisGuides shines with mid-size hypergraphs and it allows detailed analysis. We tested VisGuides successfully using publication datasets and data from historical documents.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. With Tableau, you can keep on asking questions in the data until you discover the root cause. Share your analysis securely. Your entire organization can access these interactive dashboards from any browser or mobile device to find their own answers. Tableau. Answer questions at the speed of thought.
Ecosystems are complex and dynamic. To investigate the dynamic nature of ecosystems, we have developed a prototype of a visual analytics system based on empirical dynamic modeling, EDM. EDM is a set of analytical methods rooted in nonlinear state space reconstruction. Integrating EDM with dimensionality reduction, brush-linked visualizations, and visual summarization support understandings of ecosystem dynamics.
When visualizing data in a realistic rendered 3D environment, it is important to represent the data in a readable way. In our work, we investigate how the opacity affects the readability of a 2D shape and determine useful opacity ranges. Therefore, we performed a user study with different overlay configuration like filled, striped, and dotted pattern, their density, and considered the effect of an outline.
When developing a deep learning model, people typically struggle to optimize hyperparameters that affecting the model performance. To relieve the pain of this manual trial process, AutoML has been developed as a solution. However, to maximize the potential of the AutoML, people should identify a good AutoML setting for their task. Hypertender helps to maximize the potential by visualizing AutoML algorithm behavior and guiding effective hyperparameters.
Billions of biologging records reflect animal behaviors on many temporal spatial scales, yet segmenting the time series on multiple scales is often avoided or impeded. Hence we present our multiseg VA platform with its 3 contributions. First, multiseg VA contributes tailored visual interactive features for multi-scale segmentation. Second, we show a new visual query language to flexibly configure scale-wise techniques and parameters. This VQL consumes a domain-oriented set of techniques, our third contribution.
We present StratGraphics, an approach for designing data-agnostic and fully reusable visualization templates. StratGraphics follows the inverse workflow that common data-driven systems. Rather than starting from data, designers construct visualization structures without relying on a data schema. Data tables are shaped later from the structure of graphics. We demonstrate the power of the approach through a gallery of visualization examples.
Spot SDC is a visualization system that helps researchers understand the resiliency of HPC computation kernels to silent error corruptions. It gives you...
So, hi everybody again. Thank you very much for joining us in this second part of the workshop. Now we will have the honor and the pleasure of having the second keynote speaker, Dr. Eser Kandogan. Eser Kandogan is head of engineering at Megagon Labs, focusing on natural language processing, visualization, and analytics. Between 2000 and 2019, he worked as a research staff member at IBM Almaden Research Center, conducting research on visual analytics, human-computer interaction, semantic search, data science, search, and knowledge graph. At IBM, he contributed to several IBM products and patents in data and system management areas, and prior to IBM, he worked at Silicon Graphics in the data mining and visualization group. He holds a PhD degree from the University of Maryland in computer science. He is a co-author of Obtaining Information Technology by Oxford University Press. Moreover, Eser has been working with guidelines in already many years. In particular, in 2016, together with Hansu Lee, he published the work a grounded theory study on the language of data visualizations, principles, and guidelines, where they collected and systematically analyzed 5 books and 18 guidelines using grounded theory, extracting more than 500 concepts for the analysis of factors that influence visualization design to aid in the design of automated visualization systems. Today, Eser will talk to us about the operationalizing the language of data visualization guidelines. I'm sure that Eser will pronounce it better than me. I'm sorry for this. And please, Eser, the floor is yours.
Thank you so much. Thank you for the nice introduction. So let me share my screen.
Yes.
Is it all right?
Looks good.
All right, cool. So good morning, good afternoon, and good evening. I realize there's a lot of people from Europe here in California. It's morning. So I'd like to thank you all for inviting me to give a talk at this workshop happening virtually in Salt Lake City. Interestingly, actually, my first visualization conference was also in Salt Lake City back in, I think 2000 was the year. Anyway, coming to today, what I'd like to talk about is basically mostly the work that I've done at IBM Research, where I worked for many years. I'm now basically at Melbourne Labs, the head of engineering, and focusing on NLP and AI. I guess kind of moved to the dark side. So in this talk, what I'd like to talk about is visualization guidelines. It's not surprising given the focus of the workshop, but my focus is going to be really on operationalizing them, basically making them usable and consumable by software. So I'll talk about a lot on representation of guidelines, the language of guidelines, and then I'll also talk about systems that could utilize such guidelines for driving visual analytics. So I'll try to keep things in this talk a lot of basically a fairly high level, so you won't see any implementations. And my goal is really to put forward a framework without concerns of much implementation and focus on what needs to be in the framework. So this is joint work with my then intern, Han-Sung Lee, who's now at Google, and also later with Ulrich Engelke from Sara, the Australian Commonwealth Scientific and Industrial Research Organization. So our whole goal is basically to support visual analytics. I'm not going to define what visual analytics is, but my focus is going to be across people and tools. So I would argue that the key property of visual analytics process is that it's basically a dynamic process in that data, representations, tasks, users, devices, interaction modalities often change during the course of a visual analytic process. So typically what happens is that you start with some initial data, you create an overview to get an understanding of the overall distributions in the data, you observe some interesting patterns, you quickly begin asking lots of questions, look at different dimensions of the data, slice it in many different ways, create more visualizations. And once you find sort of interesting insights, you begin to share it with others. And suddenly you find yourself going back and forth between tools, between users, collaborating, and most likely on different devices with different modalities. And the process basically goes on and on. So this is very typical visual analytics. So, but this is basically a very dynamic process. And the goal is really, how do we make this fluid? How do we make the transition smooth, both from a cognitive perspective, but also a systems perspective? So my focus is going to be a bit more on the systems perspective, but overall the objective is to cover all aspects. So the key question is then basically, how do we support this fluid process? So to answer that question, I'd like to begin from visualization guidelines. So as we all know, there's been decades work on automatic data visualization, and starting back from McKinley's original work. And early approaches has been mostly focused on basic guidelines, mostly on perceptual guidelines. How do we map data to visual attributes? For example, length is a good attribute for quantitative attributes, as it provides basically a good accuracy, right? But mapping to length may not be good for ordinal attributes, or even less suboptimal for nominal attributes. So as you can see, even in this simple perceptual guideline, we quickly begin talking about the various factors that influence the process, such as levels of measurement, so like ordinal attributes, nominal attributes. Though I didn't say it out loud, the underlying assumption was also that maybe we're doing a task like a comparison, so that the lengths and it can be easily compared. If the task we're interested in is maybe ranking or something else like clustering, then basically maybe length is not the right choice. So the point is that there are other factors, often non-data related, such as tasks and maybe cognitions and whatnot, that basically heavily influence the process. I also mentioned accuracy when I actually brought up this thing. So often there is a trade-off in making choices for the right visualization. So that was then. Now, most recently, we're seeing a lot of focus on using machine learning to basically apply to automatic visualizations with large bodies of data and visualization. And my biggest concern in that space is that they operate with limited variety of input, because the data that they can collect is basically they can have the data to train the models. They have the data sets, maybe they have the visualizations, maybe some schemas, but no input goes into these machine learning models that consider users, that consider the task, that consider the devices, because that information is not available at scale. So another concern is that these machine learning models, as we all know, they are black box models. We don't know what's going on inside of it. And for the most part, that in my view renders them basically hard to use in making trade-offs like the ones that I was talking about, which I believe is a must when we're thinking about a complex human-machine collaborative process where there are a lot of factors and there are people in the midst of it. We constantly need to make trade-offs. So a while back at IBM, we conducted a study with my intern with the goal to understand the form and the content of visualization design principles. The goal was to examine the guidelines from basically a lot of different kinds of sources and domains. And the idea was, how do we basically inform the design of automatic data visualization approaches? I was mostly focused on automating this whole process. And I was mainly, at the time of the study, interested in the language of guidelines. So we used basically grounded theory framework with iterative multi-level coding of our data to basically to do our analysis. So grounded theory basically provides a nice methodology to answer questions like what concepts are there, what are their properties, and how they are related to each other. So it makes sure, the theory makes sure that these emerge from the data, emerge from the analysis of the data during the process. So like Alex said, basically we use 5 books and 18 papers as a data source for our guidelines. So we extracted basically sentences from the papers and books. We came up, I think, with about 550 guidelines, and they were each ranging quite a bit from like as few as 5 words to 140 words. Quite a variety of basically guidelines. So this is one example. Always extend bar charts to 0 baseline, right? We all agree probably in most situations. So here, what we did was basically we coded this sentence. So we looked at things like bar charts. What's a bar chart? Bar chart is a class of visualization. A bar is basically an element of that visualization. Here, the verb extend actually refers to the length of that element. And there's baseline that refers to coordinate systems. And overall, we also actually classified the sentences as basically and in this case, imperative expression. This is a bit more longer example. Line graphs should be used when individual values are important, as length and position are easily quantitatively perceived. So I won't fully describe this, but what's important here is that there are conditions in these guidelines when individual values are important, which references maybe inherently a task that one, or in insight that one needs to gain. The individual values is what we are interested in. There's also casual expressions in here, maybe sort of like an explanation. So as length and position are easily quantitatively perceived, which references actually not only visual elements, but also the user's cognitive functions. So basically, even from these two examples, you can see what we came up with in our iterative coding was that we sort of identify 5 high-level concepts: data, visualization, user, insight, and device. So let me go actually in each of these a little bit more. So data covers all aspects related to information: the attributes in the data, the schema, the operations, the domain of the data. And visualization covers all basically aspects related to form, the visual representation of data, and also interactions such as basically the elements in the visualization, the bar example, right? And the attributes, the length, other components, the legend and access, and the operations, grouping them, or interaction things like zooming in and out. The user basically covers all aspects to the person basically viewing and interacting with the visual representation of data. So things to consider here are basically their abilities to be able to read and recognize and recall, as well as like social aspects, right? There are certain conventions in basically in certain domains on how to visualize stuff, and as well as their tasks. Insight here refers to all intuition, understanding, and knowledge to be gained from data visualization. So things like trends and outliers and individual values and relationships and variances and whatnot. So insight is basically naturally related to users' tasks. And the way I think about it is basically insight is more like the outcome, and task is basically maybe the process. So device here basically covers the physical aspects of the visualization medium, particularly related to display and interaction capabilities. So in addition to these 5 concepts, we actually came up with some other concepts. And one was basically this concept called qualifier. And the idea was they're basically used as a refining or contextualizing concept. Just to give you an example, maybe a guideline may refer to a specific quantity, such as when there are 2 nominal attributes, or when they refer to a less defined quality like large data sets and dirty data and things like that, right? So we identified in our analysis about 35 such qualities basically in the guidelines that people talk about. All right, so what we did was basically, it's not just these 5 high-level concepts, obviously, we basically further refined our data, and in each one of them, we have basically some hierarchical codings. And the example here is basically data is the highest level, data attribute is one aspect of it, data attribute to measurement level, and maybe a specific even measurement level type. So we coded all the data in all these 5 high-level concepts with all these with finer levels. So that was more at the concept level. And so part of the goal with the grounded theory is also finding the relationship between these concepts. So that's what basically this second level axial coding is in grounded theory, involving basically trying to understand the relations and the conceptualizing concepts. So to code relations, we created an expression concept, and which basically entails logical relationship between concepts, or equality or similarity or existential when there is like 2 or when there are too many, right? Things of that, or ranks and propositional relationships. So in addition to these, we also have basically groups of concepts which may be related in the way the guideline is formed or the guideline is talked about, representing conditions, like in that example, the second example and that I gave, or copulative, basically ands and furthermores in the guidelines. We also noticed a lot of like causal due to kind of thing examples, or adversative, buts, and supportive relationships. So these are basically related to more to the way the guidelines are formed, but like we're in the earlier discussion, we talked about the relation between guidelines. So these kind of go into that space, like in terms of like, you can apply this, but when something happens, you basically go with this other thing. So these basically connect the guidelines in the way they're talked about. So based on our study, we did a lot of analysis, which I'm not going to go into too much detail, but just give you a nature flavor of what we came up with. So we examined the content of these guidelines. We codified each one of them with these multiple levels. And one thing that we looked at was basically what are the associations between these concepts. So basically in a sentence, if basically there's a mention of a user and a supportive expression, right? So we basically try to find those kind of associations. Obviously in the data, there were a lot of basically associations between visual and data attributes. Actually, like a lot of guidelines talk about visualizations and guidelines, and there we found, to be honest, much less on tasks, much less on users, much less on interaction. So this is basically the reflection of the basically the guidelines so far. But we found basically a lot of stuff that sort of relate to the original perceptual guidelines that we talked about. We also found some associations between tasks and insights, and to do comparison to get something sort of certain specific insights. We also found some basic associations between user abilities and visual attributes. So basically, a lot of the content about this is basically in our paper. I'm just giving you a flavor of the kinds of insights we extracted, specifically on the content. So our focus was also basically analyzing the form of the guidelines and basically the whole sentence. So we classified guidelines as instructions. So basically describing what should be done, right? That type of thing. And there are also guidelines that sort of are more like rankings, right? Comparisons, stating preference of one guideline over another, or one concept over another concept. And we also found guidelines that are more explanatory, like providing a reasoning beyond the suggested statement. So, and then we basically divided the data into each of these, and we analyzed what are the top patterns in instruction guidelines. And basically, not surprisingly, we have seen a lot of like visual attributes, color, size, position kind of concepts in there. We also analyzed, in the conditional guidelines, what are the conditions mostly? So without going into too much detail here, because basically we saw conditions such as when there's an attribute or of a certain measurement or of a certain semantics like temperature and whatnot, or in a specific range or a certain distribution of the data. So things like basically a data has long labels, data contains time, or there are 10 bars, or large data set, hierarchies in data. So these are basically all examples of just the conditional part of the guideline. So there were many more insights, and like I said, I'm not going to go into much of these details. I mean, the paper has a lot of them, but our focus was basically on, in this context, in the context of this talk, was to analyze the text, the form of these guidelines. So the conclusion I want to focus today is basically not so much on the content of guidelines, like I said, as in like specific recommendations, but more on the form of them. So the key result basically from our study with that respect was that there's a lot of variety of factors for effective visualization design, including aspects of data, visualization, user, and insight. And these factors come into play as causal, contextual, and logical relationships among them. So when we think about the visual analytic process, then going back from all this, my take is that we need a holistic approach to the design space, considering basically users, data, visualization, interaction, and tasks and their devices. And we need to be able to describe them in a language and maybe even an algebra of visual analytics. And overall, we're thinking in a sort of like operating in a mixed initiative system that allows users and systems to work cooperatively. And where does guidelines come into form? Basically, we need to be able to leverage into guidelines. And I'm going to argue actually formally describing the guidelines if possible, and not even just for consumption by computers, but also actually for people. And I'm basically going to argue for repositories of guidelines. So how do we approach this? What is the framework where all of this can come into together in a mixed initiative, human computer cooperative system? So I like to think about this basically visual analytics process as a state flow in which we move from one state to another as a result of either users interacting, users doing certain things, or computer recommendations on computer basically going through processing the data. So the quick question is then, what is this one state? What do we need to have in this particular node? And I would argue that this actually comes from the study. The 6 facets of the state are data. Here actually separated the task. Originally it was included in the user, but basically data, task, users, the medium is basically device, visualization, and interaction. So if we represent each node with information about the data, task, users, and whatnot, we can then begin to think about this a bit more systematically, move from one state to another state, either through users doing it or basically the computer actually doing something. So basically, as we move from one state to another, maybe the data change, right? Maybe we filtered the data, or the task might have changed. Now I'm thinking comparison or ranking and whatnot. Or the users might change, right? We think about basically collaborative systems. I might give basically Alfie a suggestion, oh, look at this visualization, right? So now it's basically on her part. Or the medium may change. She might have a different device, the visualizations, the interactions, so they're all gonna be basically changed. So what I'm trying to represent is basically capture this whole visual analytic process in a very systematic way. So basically, these transitions might happen as a result of internal competitions, meaning that the system, which I call it here, the inner loop, the computer basically might change one facet of the representation at a time. The computer might decide to query the data or find insights, iterating over maybe guidelines to find the right mappings of the visualizations, but they're basically each operating and moving the state diagram. Not everything, not every state in this flow need to be externalized, obviously. So basically they can be chosen when to be displayable, visible to the user. So these transitions also happen basically as a result of users' actions. User might be interacting with the visualization, maybe selecting a bar or filtering a data, or maybe they might be moving into another insight or task. So they might even be creating themselves visualizations, mapping data, choosing the various dimensions to display, right? There are many things. Where do visualization design guidelines come into place? It's basically either users or the system taking them and basically as a way of guiding the next step, as a way of basically moving from one state to another state. That's basically how I'm seeing it. This guidelines fit in this whole framework. So let me walk through an example. Hopefully it will make things a little bit more clear. So basically think about a user, a lobbyist at an environmental agency advocacy group, and she's basically analyzing a survey data from the Australian attitudes to climate change data. And basically her task is understand voters' beliefs in climate change. And she works basically on an iPad, which she takes basically with her when talking to legislators. So one oversimplifying way to represent this user, and maybe just even focusing on expertise areas, is something like this: expertise, analytics, intermediate, visualization, intermediate, environment, advanced. So I'm not arguing like this is the form or this is, we just need to capture expertise. What I'm arguing is basically we need a system where we can structure in a structured manner, collect information from the users if we were to make support this whole fluid interaction between computers and systems. We need to know more about the users. That is basically the argument to put it. The data, so basically survey data, there is attributes about age, gender, location, belief, and politics, basically referring to the political party. Task is basically understanding the belief attribute in the data set. So he's basically one representation of that statement. And a very simple representation of the medium is basically, 10-inch display, and basically she might have a touch screen. So at the beginning, the first initial state is basically we don't have a visual interactive interface, right? We just have the data, user, and the interaction and visualization is basically empty. We don't yet have a visualization, but through the process, we're gonna basically create and put more interaction in it. So at the beginning, it looks like this. We have the user, we have the data, the task, and the device. So what I'm gonna show is basically two examples of how to move from one state to another. And one of them is gonna be a user-initiated transformation, and the other one is gonna be more like a system-initiated transformation. So let's do the user-initiated transformation first. So basically, she might come in and think about this overall high-level task of understanding belief and maybe pursue 3 different subtasks. Maybe look at the overall distribution of the belief attribute values. So what's basically the overall, the values across the board, how many people are in which bucket. Another way is always like slicing and dicing, right? So examining the distribution by the political party or examining the distribution by location. So these are basically, and you should think about this from this state. Now we have basically 3 more states to follow. And she might pursue each one of them in sequence or in parallel. So an example of a system initiated information is basically, I'm going to just do a simple example, creating a visualization by applying a guideline, and such as maybe a map data attribute with a ratio measurement to the length of the visual element. So this isn't enough by itself to create the whole visualization, but what I'm going to argue is that by applying a series of these different guidelines, we can construct a visualization. And this is basically what it's going to look like. So the first guideline, we have a number, 12. Maybe it's the number of basically people who believed in a certain way. And we actually, and it's basically a hidden operation here is basically that corresponds to 4%, but we basically map that to a length of a visual element. And then applying another guideline, map a data attribute with an ordinal measurement to the color. So we mark that as basically the Labour Party is the red color. We do this on different parties. Now apply another principle, group visual elements of data attribute with ordinal measurements. And with one more time, you create basically a richer visualization. So coming back to this figure, basically I'm arguing for modeling the visual analytic process as a series of transformations, an inner loop and outer loop as a way of capturing this mixed initiative nature of the process. So as you have seen in the examples, in the outer loop, the user makes the decisions, maybe such as breaking the task or doing other stuff, visualizing basically different dimensions. And in the inner loop, the computer may make basically a series of transformations, and eventually maybe at one point it's represented as a visualization that is presented to the user. So there's value, secondary value in capturing this whole thing as a state diagram, as it actually represents the complete journey in the analytic process. And this can be used as a data source itself. We can actually mine into this to create and extract insights on basically how to guide this whole visual analytic process. So one can imagine basically creating recommender systems out of these data sets. So with that, I would like to conclude. So as we move towards more intelligent systems in support of driving and participating in visual analytics, what we need to be thinking about is basically, we need to think about comprehensive representations that cover all aspects that are important: users, data, tasks, and devices. And we need to be basically thinking about languages. How do I represent this as basically the data, or how do I represent a user? How do I represent each individual pieces? But also the guidelines, right? How do I represent the guidelines as a computer consumable representation? Maybe we can have knowledge resource about these guidelines. And overall, basically, we need to have mixed initiative systems, and we need to be able to iteratively transforming and guiding the visual analytic process. So with that, I'm open for questions.
Eser, thank you very much. This is really a very interesting, exciting talk. I have many questions, but maybe we start with some of the questions from the audience or the panelists. We are running out of time. We have only 3 minutes if we follow the schedule. So I would say, if there is any questions, just write it now in Discord or in Discord or in the document. Otherwise, I have a question, 2 questions. I already wrote them in the document as well. All right. So guidance for guidelines. So one question here: how do you compensate for potential biases in selecting the guidelines?
Right. So that's basically a lot of the machine learning, applying machine learning to guidelines is in a way, there's bias in the data, right? So in the sense that, I mean, there's a lot of guidelines about like pie charts. This was sort of like discussed in earlier discussions today. And I don't know, to be honest. So when we put things into more systematic approach, there will be many alternatives to pursue. I think one potential approach might be that as we start basically collecting this data, these journeys through more detailed approaches, we might begin to get users' feedback into these. Maybe there was a recommendation of certain, but the user went through another path. And overall, we can basically build a more reliable data source of that's learned from the user's activities. That's one potential way of seeing it. But like I said earlier, guidelines, quite a bit of them are biased, when for the most part, in some ways, the context is removed. So the overall goal should really be learning about, in a way, how do we guide, how do we learn, how do we build a model between these guidelines? How do I actually know when to apply which?
Mm-hmm. All right.
Sorry, I think my talk ran over, but I'm actually open to offline questions later on. I'll be happy to answer them as well.
Yeah, so it's very interesting your perspective really open. It's very interesting because you have this strong machine learning background that you can bring to our community, and the thing is key what you just said about the feedback of the user, right? Incorporating this, and the fact that you mentioned this dynamic process, right? I wrote a question, we don't have time for that, but it's a dynamic process, you said, right? And so I suppose that this bias could be compensated over time as well.
Yeah, I mean, that's the thinking. So basically, when there is bias, we need basically more input, more corrective signals into the systems that we're building. And that's the only way to do it, to be honest.
Mm-hmm. All right. So we invite everybody who has more questions, please write it down in our document or in Discord, and or reach Eser personally afterwards. Now we have to continue with the second panel. Thank you, Eser, again.
Thank you.
So there are many things that we can discuss. This is very exciting. Welcome to this second fascinating panel. We have discussed and learned a lot from our previous panel about guidelines in the teaching context. And now we are going to dive into a very timely, urgent, global, societal, and scientific topic as well that concerns us all, and where many scientists, starting with our panelists, are making gigantic efforts to find answers in the data, construct hypotheses, and communicate the multifaceted nature of the data from the pandemic in which we currently are effectively and efficiently in an emergency setting. We have highly recognized scientists that will give us their viewpoints, recommendations, and lessons learned when applying visualization in the wild, as we call it, in this emergency setting. We will talk about knowledge transfer from our visualization community to the public, guidelines and recommendations to unexpected, urgent, and vital situations, and the lessons that they have learned during applying these visualizations during this process. We will look at how we apply our skills and knowledge in such situations, in the context, and how we express our design knowledge in a multidisciplinary setting. We will also carefully address our position in society, where we are now and where we can be next. How can we improve and reflect on the lessons learned by scientists in our community and abroad? The panelists, as Benjamin said before, then just by alphabetically, and so I will be listing each one of them now. Our first panelist is Professor Sara Irina Fabriknat. She is a full professor of geography and past head of the geography department at the University of Zurich, Switzerland, where she's leading now the Geographic Information Visualization and Analysis Group. She holds a PhD in geography from the University of Colorado at Boulder, United States. Her research and teaching interests lie in geographic information visualization and geospatial visual analytics, GIS science and cognition, graphical user interface, design and evaluation, including dynamic cartography. She's also the co-director of the University of Zurich Digital Society Initiative and a member of the Swiss Science Council. Our second panelist is Professor Alexander Lex. He is an associate professor of computer science at the Scientific Computing and Imaging Institute at the School of Computing at the University of Utah. He is the co-director of the Visualization Design Lab, where he develops visualization methods and systems to help to solve today's scientific problems. Before joining the University of Utah, he was a lecturer and postdoctoral visualization researcher at Harvard University. Alexander is also a recipient of a National Science Foundation's Carlin Award and multiple Best Paper Awards at the IEEE VIS, ACM Chi, and other conferences. Moreover, he has founded DataVising, a startup company developing visual analytics solutions for the pharmaceutical industry. Alex's main research areas are data visualization methods for domain experts, and the design, building, and study of interactive visual data analysis solutions that aid researchers in the data-driven fields such as biology and medicine in understanding and communicating complex data sets. Our next panelist is Amanda Makulec. She's a senior data visualization lead at Excella and holds a Master of Public Health from the Boston University School of Public Health. She worked with data in global health programs for 8 years before joining Excella in 2017, where she leads teams and develops now user-centered data visualization products for federal, non-profit, and private sector clients. Amanda serves as well as an operation director for the board of the Data Visualization Society and is a co-organizer for the Data Visualization DC. We will have as well Professor Cagatay Turkay. He is an associate professor at the Center for Interdisciplinary Methodologies at the University of Warwick. And before that, he was first a lecturer and a senior lecturer in applied science Data Science and at the GIS Center at the Computer Science Department of City University of London. He received his PhD degree in visualization from the University of Bergen, Norway in 2014 and served as a visiting researcher at Harvard University. His research focuses on designing visualizations, interactions, and computational methods to enable an effective combination of human and machine capabilities to facilitate data-intensive problem-solving and techniques for visual data analysis. Finally, our last panelist is Professor Tatiana von Landesberger. She's a professor at computer science and also the head of the chair of the visual analytics group at the University of Rostock, Germany. And before that, she has done research at the Technical University of Darmstadt, Germany, and also at the Karlsruhe Institute of Technology, Germany, Fraunhofer IGD, Germany, and the European Central Bank. Tatiana holds a PhD in computer science from the Technical University of Darmstadt, and she has been serving our communities in many years in the Euro-VIS and the IEEE-VIS, in different programming committees, such as InfoVis and BAST. And her main interests are in the visualization, interactive visualization, visual analytics. So now I will introduce everybody. I will open the floor for the panelists to share with us their experiences in the knowledge transfer of visualization. And I will start with Sara. I will stop sharing now. So Sara.
Good, actually evening now from Zurich. In terms of, you mentioned knowledge transfer, I will also actually make the connections to the earlier panel, and that is education. Education in the sense of educating students as a professor, but also educating colleagues or exchanging information to be educated from colleagues that are, for example, in the health sciences. So just to be sure, I'm looking quickly to Alexandra and that we can use our intro statements. Is that where we can actually use them?
Yes.
Okay, great. So just that you know, in terms of context, because context is going to be my theme, I'm a geographic information scientist, so the visualizations typically relate to space and time. And as geographers, we always see that these visualizations never exist without context. And I think Eser mentioned that. One of the issues with the guidelines that we heard earlier is it's about typically context-free. And I think that's something that I would like to bring up because our context for this panel is the global pandemic. And so if we generate visualizations based on guidelines that typically are context-free, what happens if they are consumed for large public consumption and framed in the context, in this case, of a human health crisis. And I'm using this term because this is the terms that are used. So literally, we are visualizing life and death. And along those lines, of course, in the Western world, we actually use a set of, typical color schemes. For example, red means blood, stop, danger, something like that. Black maybe representing death. So what if we are using these colors in this kind of global interaction where in certain parts of the world, these are accepted colors for specific framing, but whereas other parts of the world, of course, red means completely something else. And in fact, white would mean death, for example. So these two colors, red and black, have become ubiquitous because also the technology that is being used comes from a setting. In this case, clearly an American setting and also using American technology called Geographic Information Systems by a certain company that is located in the US. And for them, they have set standards to communicate these kinds of data sets in a particular framing and in a particular setting. where we have, red circles spreading over the world and basically covering the black world, the black background. So I think this is an important aspect that we need to think about, and that is framing. So visualizations cannot be context-free, but in the sense of this global pandemic, we also use words like the fight against the pandemic, the fight against the crisis. And this framing, of course, also influences the visualizations that we see. So we have, the Olympics track and field of the red front lines, as it often is called, the red line. It's a horse race, and then typically these lines move fast, they move steeper and higher, and then we use animations, at least in some of the interactive versions, where literally we have this hit parade and this horse race unfolding dynamically. So my question here for the panel and for the people listening, how can we then use our design guidelines that are mostly well-intentioned, perhaps intended context-free, if we are using them in this kind of framing? And the question here would be, what would be the positive framing? So this is the negative framing of this pandemic. What would be a positive framing, and what would the guidelines then look like? So what are these role models of ways to do things in a good way that we can sort of hinder this quote unquote pandemic? So this is basically what I'd like to bring up, because the framing is more important than we think about if these visualizations are used by policy decision makers and then making very important decisions for large groups of people. And so what role does then, in this case, that expert and the design guidelines, what do they play so that we actually can create, turn complex scientific data into clear and understandable visualizations, and also carry through this empathy that we have actually to solve a problem. So that's for now. I have lots of other questions, but I think I'm going to leave it at that. Thank you.
Thank you very much, Sara. But I already wrote down your question, so we will pick the question again after all the position statements I presented. And now is the time of Alexander. Alexander asks me if we can share the screen. The answer is yes. Welcome, Alexander.
Great. Yeah, I'll talk a little bit first, but I want to show some examples later.
Yes. Okay, great.
Thanks. Yeah, so I wanted to talk about 2 points. I think within the visualization community, it's been fairly well discussed, the ethics of actually building and publicizing visualizations of COVID data. So Ben Schneiderman has kind of written a blog post or an article about this is kind of visualizations breakthrough moment, right? And Michael Correll has criticized people just oh, look at my fancy visualization technique. And that's really not the time, in his opinion, to do that. And so I think there's a little bit more nuance necessary here, because the first question, should you build and publicize a visualization of your COVID data? And I would postulate that the answer to that is probably not, unless you're really careful and or work with the right people. So I think it's totally fair game to, let's say, work with your local health department and help them build dashboards to inform, let's say, the local population of your state or of your region or your country or something like that. But maybe it's not the right time to really say, to really show off hey, here's this fancy visualization technique I built a year ago, and now I'm showing just some snapshot of the data, use it to essentially promote my visualization technique. One little caveat here is this isn't maybe quite as problematic anymore as it was 4 or 5 months ago, because now people have kind of reached some kind of saturation with information. And so I think that people are now pretty literate, or at least the people that care about this kind of stuff are pretty literate about the data that we have on coronavirus. And so it's not quite as black and white anymore. But I definitely do think that it is okay to use COVID data to demo your visualization tool in, say, a scientific paper, right? we are using these kinds of like societally relevant data sets all the time, and really nobody wants to see like the cars data set from the 60s anymore, right? This is kind of like, we have more engaging data sets. But so the other point I wanted to make is, of course, if you build a data visualization for the general public, then it's really, really important that you bring in context. And so this is also where my position is very similar to Sara's, but I'm kind of using context here in a slightly different way. You shouldn't give like a simplistic, overly certain view. The data for coronavirus is very complex. It is very uncertain. And your visualization should acknowledge that. And so what you need is annotation, contextualization, embedding with text and data stories, and so on. And I should add that a lot of newspapers are doing a good job at that, but there is like certain, like let's say, black sheep out there. And so I want to show two examples now. So here is kind of like as bad as it gets example, in my opinion. This is the coronavirus dashboard that's kind of like promoted by the Johns Hopkins University. And I think this is kind of like Sara mentioned, this like killer circles on like red killer circles on top of geography. So this is like, this doesn't tell us anything, right? The map looked the same for the last 6 months. It doesn't really give us a lot of information. It doesn't show us how things have changed recently. And do you really believe that we have exactly 42,776,017 cases? Like that just seems bizarre, right? To try to state something like this with this kind of certainty or like precision that kind of communicates certainty. And so, yeah, this is a terrible visualization. Johns Hopkins is doing a great job collecting this data, right? But the communication here is really problematic. And I think a counterexample that does a really excellent job is Our World in Data. This is by like Max Rose's team at Oxford University. And what they're doing is, it's really like, you can see this is like a very long form data story, an article with kind of like a data explorer, and you can kind of dynamically switch between different perspectives. I can say like confirmed cases or confirmed death. I can like normalize it to per million people. I can align outbreaks. I can filter into the countries that I care about to kind of see what's going on with them. And there's like a lot of different views. There's like stories about individual countries. So it's kind of like pre-authored and gives you interesting perspectives. And it also links to all the data constantly. You bring in like it is very explicit about uncertainty and so on. So I think this is really a great example of how to do it right. There's of course some little things here that are not always so great in the visualization techniques, but I don't want to nitpick about that in detail. I think overall they're doing a great job. So yeah, that's it, and I'm looking forward to discussing this a little bit more.
Thank you very much. Alex, then now the floor is open for Amanda.
Thank you, Alex. So I'm coming here with less of an academic perspective and more coming as a public health practitioner who has been working in data visualization and with data for almost a decade. My roots are in public health though. And so as I look at the data about COVID-19 and how we've approached this as a data visualization community, I think about this from the perspective of how are we communicating to individuals and also to policymakers. And so while I absolutely respect the perspective that perhaps we are at a time where people have better understanding of the coronavirus data set, I don't think that we're at a place where we can say that it's the right demo data set for a data visualization tool, or even a data set that we should use for learning. For example, we have a number of people, especially here in the States, who have lost family members or been personally impacted. And I think thinking about the ways in which there could be a personal impact to folks by having to work with and look at that data set that really represents lives lost in an emerging still pandemic where many countries are entering their third wave, I think is irresponsible. And so I'd like to talk a little bit about some of the learning that we've had and why I think that this is a moment of reckoning in some ways for the data viz community to reflect on how we approach COVID-19. And I think a big part of that is that there was this initial enthusiasm for creating new charts and trackers, and that's still there to a certain degree, juxtaposed against a very small amount of subject matter expertise in public health, epidemiology, health information systems, and all of those other underpinning contextual factors that we really need to build effective, well-communicating visualizations. Case data has been easy to source, as Alex mentioned, but that doesn't make it easy to understand. And as we saw these different various data visualization tools like the Tableau COVID Hub spring up these different ways of jumpstarting your own analysis with this ready-to-use workbook, back in March, that prompted me to write an article talking about 10 considerations before you make another chart about COVID, that I'm sad to say is still relatively relevant. And I made the plea that as a public health professional first, might I ask, please consider if what you've created as a visualization, a tracker, a chart, serves an actual information need in the public domain and add value and uncover new information. Not to say that individuals can't add great value through their visualization work in this current crisis, but it takes time and effort and additional subject matter expertise collaboration to do that effectively. And so perhaps this is a time that we shouldn't be publishing things just because they're popular. We were faced with the challenges that timeliness of the data or lack thereof and uncertainty in that data creates a lot of challenges for creating effective visualizations that try to summarize and show patterns in information. We see that in some of the noise that we see in various different reporting periods. This is a simple data set from the state of Georgia here in the US that has big caveats in the footnotes, which I would argue that many people choose to ignore, which is why thinking about ways to answer questions of what's happening right now are so important visually, which is where data visualization experts can be so helpful in thinking about ways that we can encode that uncertainty in our charts and our graphs in effective ways. I think that ways that we actually show that visually help to draw attention in ways that footnotes and annotation layers may not. We also have to think about the timeliness of when data shows up in our data sets and that the point at which someone is exposed and could be transmitting virus to someone else is a few days before they may have test results represented in a database, which means we have to think about the public health ramifications of the recommendations that we're giving to folks. This is an illustrative timeline that took almost 11 days from the point of exposure to actually having results in a database back in June in Washington, DC. And as we look at these processes, there are a lot of complexities to how that data gets collected. And when we think about health information systems, we have to think about the ways in which these different systems create complexity and lags in information and timeliness issues for us and how we understand what the current prognosis is locally of COVID-19. I did a series of journey maps with an illustrator doing interviews with some of my public health colleagues, understanding what this looks like in different locations and different countries that have different informatics architecture. And we've seen the issues around preprints and different pieces of information being spread, not just through the various COVID case numbers themselves, but spreading preprints and pieces of information that are summarized often in simple visualizations that ignore the immense uncertainty in the numbers or the denominators that we just don't know early on. This paper far off to the right-hand side that Reuters talked about back in February was eventually debunked and removed as a preprint because it was something that was not actually validated through peer review. And so we've seen a lot of scientists speaking out on Twitter and other spaces, plucking up and saying, hey, I saw this visualization that's being widely shared, but it's not communicating good quality information. It's not informing the public in a meaningful way. One of these from Carl Bergstrom is from months ago. This one on the left from Ellie Murray, looking at this scatter plot of masking and looking at people who know someone with COVID-19 versus wearing masks. That's from yesterday. And so I think there's still a great relevance to us thinking about the ways in which our visualizations might mislead or not. So when visualizations inform choices in an emerging public health crisis, I think we have to emphasize the do no harm principle first, and that still holds as we continue to learn things about COVID-19. Bridget Cogley talked about this as she thought about value prioritization and the ethics of visualizing COVID-19 and focused on the fact that we should think about this more in the midst of a pandemic, and further went and dug into the fact that there were many different visualizations created, but very few updated, and calls to action were often not modified as public health advice changed, which means that there's poor advice and information out there on outdated visualizations sprung up just out of novelty or interest, and not because we thought about the impact of our work. So I would argue that I think that our best collaborations still happen from bringing these two spheres together, public health experts and data viz designers, which encompass a number of different specialties and areas. We can't just pluck and focus on the epidemiologists. We can't focus just on, say, the data journalists. And the more we create these kind of collaborations, like we've seen at places like the New York Times with all the bootstrapping they've done to gather data, the more we can actually learn more about the nuances of this pandemic and who's being affected. We did go ahead and try to take a stab at the ethics of visualizing COVID, and I would welcome more conversations about how we actually reflect back on the last 9 months or so, what we've created, what we didn't create, and how do we effectively help ourselves kind of rise up as a community to learn from those experiences and make sure that we don't make some of the same mistakes in future public health crises.
We can't hear you, Alex.
Alex, you're muted.
Yes, sorry. I was just trying to collect the questions on Discord and like I messed it up. So thank you very much for the patience. So now our next, thank you very much, Amanda, for your perspective. Very interesting. So now our next panelist is, please, Cagatay, go ahead.
Thank you, Alex. I guess I will follow on from Amanda's last point on collaboration and try to sort of talk a bit about our role as a visualization researchers engaging with experts. And so in that sense, it will be coming from maybe a different perspective, not so much on the public communication, but a bit more so on how we work with experts. So some of these reflections and some of these thoughts are from an ongoing voluntary contribution that me and many other visualization researchers in the UK are making within the context of a Royal Society initiated response to the pandemic in the UK. So one of the distinct aspects of designing visualization in the time of the pandemic, and several of us sort of experience over summer and then and late spring, is the time pressure. So there is time pressure both in terms of delivering what needs to be delivered. I mean, that's obvious. So these are sort of greatly needed by several people. But there's also time pressure on the people that we want to collaborate and work with. And then what our collaborators can offer us as visualization researchers. So then we find ourselves in this mode of operation that we need to sort of produce designs rapidly and quickly. And of course, one very effective approach is to use whatever tool and platform we feel most comfortable with to provide some quick and dirty solutions to sort of support our collaborators working with data and their models. I mean, this is reasonable, perfectly reasonable from a technical perspective, an operational perspective, of course. But then one challenge here is, and one danger is that we might be skipping some essential phases of the route or of the pathway to effective visualizations. So we sometimes don't have maybe the time and capacity to do sort of user engagement or sort of task analysis, maybe sort of activities like participatory prototyping. So that valuable user research may not be necessarily there. So there is a danger. That's a threat that could frustrate us in the end and sort of could lead to sort of visualizations that might not be operating as we want them to be. So considering these pressures, I would like to argue for two aspects that are really of importance in these periods. The first is that the need for an open, supportive, and dynamic collaboration between us as visualization researchers and the domain experts that we work with. And this is particularly important because we can use these collaborations to provide some rapid but yet insightful user research. I mean, there are established methodologies such as rapid ethnography and rapid reviews and things like methods like that could help support such activities. But those activities require really reflexive and intensive engagements with the stakeholders. And the way to be able, I mean, the only way that we can engage with such intense engagements with the stakeholders is to have a strong, healthy relationships with them. And that is built on trust, and that is built on respect, on mutual respect between us as visualization researchers and the experts. So I would like to sort of argue that this first phase where we built that rapport and then relationship with our collaborators is of utmost importance, maybe more than so in any other projects, because that's what like useful and successful design will build on. The second perspective that I'd like to sort of highlight, which is also related to the topic of the workshop, is that we need well-established guidelines, maybe more than before in these periods, because we need to sort of produce some early designs and early iterations of some of the designs very quickly in these time-pressured ways, and within that early phases, especially when we are lacking that valuable user research, guidelines become extremely handy and extremely important to guide our sort of design. And also it's interesting, also important that those early designs are also quite influential in building our relationship with our experts. So they become even extra important. So I'd like to close by saying that the pressures of the pandemic challenges us in many different ways, carrying out the design studies in ways that we normally used to. But as visualization research is therefore extremely crucial to build healthy relationships that can underpin this rapid yet insightful user research. And it's also more than ever important as a community to build guidelines for further future challenges and then to help us guide in those stressful times. So with that, thank you very much.
Thank you, Tatai. Now we will give the post to Tatiana, our last panelist in this round. So Tatiana, please go ahead.
Dear Alexandra, thank you very much. I would like to thank all the panelists in front of me. This is a really great journey from the public visualization for everybody, design guidelines on a general level up to a very, what Cagatay meant, user-centered design in a rapid place. And I would like to continue in this journey and show a small example from our work that serves as an example for this type of for my talk. I don't know how to share my screen. I hope that that's possible.
There is a green button
on the bottom.
Green. Mm-hmm. So just to give it a small, can you see the slides?
Yes.
Okay, so just to make it more explicit. So basically, I would like to continue on what Cagatay said from a real example from our work that we did together with hygienists and infection control experts in Germany. And interestingly, at the time when the pandemic started, we were just finishing a 2-year project on exploring outbreaks and pathogen transmissions in hospitals. So we were at the end of the project that was done together with 7 German hospitals in Germany, and it was focused on multi-resistant pathogens, MRSA, and using real patient data, who has contact with whom for how long, who is infected, and so on. And we had several design rounds over 2 years. So we started a very simple visualization and making it more complex and adjusting it, and had several rounds with the users, on-site discussions, very close cooperation. And if you would like to know more, there is a talk on Friday And after those 2 years, we came up with a design that was ready to use for analyzing outbreaks in hospitals. And at this time, COVID pandemic started. So we were asked, like, can you adapt it very quickly to the COVID data? And we thought, okay, that's easy. We already have a ready to use visualization. It's the same task. It's almost the same data. It's either it's a pathogen, bacteria, now it's a virus, easy. And we had 4 weeks to do that. And however, that was not easy at all because this work was done during the lockdown period. So there was no way of discussing with the users at the same time and having several rounds of discussions. More or less, there was privacy issues with the data. The data was not available at the time when we were adapting to the visualization to basically non-existing data. So this was the first time developing visualization without having data, because the data collection was at the same time as we tried to develop the visualization. And this everything had to be done within 4 weeks. So from that, we learned a lot about challenges when adapting visualizations to new cases. And we learned also that it can work if you have a really good team that works together. And we need adaptable visualization guidelines. So something that already is, we have experience with, we have established guidelines, standard guidelines that can be easily adapted to new cases. And we can develop new quick solutions only when there is already enough experience of it. So this goes together to my call on really establishable guidelines, some kind of standards that can be adapted to new cases. And yeah, and with that, I would like to also thank all the research community that helped us to develop this and start up the discussion about how to establish those guidelines and how to establish processes for quick design processes in our community. Thank you.
Thank you very much, Tatiana. Meanwhile you were talking, I've been thinking all the panelists that how society can profit really a lot from your work and from your ideas, and that this transfer of knowledge is something that we need urgently. I will share again my screen. Give me a second. And are there any questions in Discord? Let me check.
There are in the document.
They are in the document. Perfect. So let's go to the document. So we have the first question that I wrote here. It's from Sara, and there is what would be a positive framing? How would guidelines look like if we take into account this positive framing and for policy making? I don't know if, Sara, do you want to add a little bit more on that, or shall we continue? Some other panelists want to add on this aspect, because this is one specific aspect that I think we haven't, so at least myself, considered so much.
Maybe can only share a little bit where I'm coming from. So the question here would be, we are considering users, we are considering tasks, typically in the design sciences, and I'm including cartography for geo-visualization designs or maps. And but I think context, and then I completely agree with Lex, context can mean many things. And amongst one, it could mean, we're mapping climate change or the pandemic. And I think the same visualization guidelines, and also I'm referring back to Eser, who's mentioned, in fact, the current ones do not consider explicitly context. So I can use the color red for showing, growth, wealth in certain regions of the world. And I can use the color red to make a point about danger, stop, and blood. So I think that's something I wanted to get at. So if the same data that we have about the pandemic is visualized in different ways, does and how it might influence policy and decision making. And we know from actually empirical research that just the change of colors will impact how people think about an issue, and then also will decide about an issue. And I'm relating back to a study that we've done with brain mapping neuroscientists in the context of climate change, using the same principles for brain maps, applying them to geographic, cartographic maps, framing it in one sense on brain diseases and in the other sense on disease of the planet, and seeing how actually by changing the color scheme, just that, how actually people would be more or less willing to engage in ecological thinking, and or would be, deciding to switch off the machinery because someone is brain dead. So I wanted to elicit this by my question, how framing and the context will impact these design guidelines. So that was my initial intention.
Thank you. Some other panelists want to comment on that?
As you think about the audience pieces, might I raise the point or the question, I'm curious if others have found ways to address this, that as you think about different audiences with varying degrees of data visualization literacy, but also health literacy, and looking at the different populations who've been most disproportionately impacted by COVID, how we think about and have a more nuanced understanding of who that audience is and what different techniques or approaches we might adapt to make sure that we're developing graphics that are culturally relevant and the language is culturally appropriate, not just in using the different languages, English, Spanish, Amharic, but rather thinking about kind of how that content and information and those recommendations backed up by data are communicated. And I'd love to know if any of you who are more imbued in the research space have found effective ways to gather that kind of insight and adapt visualizations, but doing it rapidly, which is the other challenge that one of our other panelists addressed in terms of disseminating information in the current environment.
I think the answer to that is no. I don't think we have an idea, right? Like we don't have visualizations that, like, it is a hard problem, right? Like how do you measure literacy? How do you adapt it dynamically? And designing for all of these different cases, it's really tricky. So I think the best way I can think about this is like as a layered data story, right? Where you kind of start off with something simple and then dive into more complex situations or more complex cases as you go on.
All right.
And maybe, I mean, I would say with, I agree with Alex. I think I wish we had enough knowledge into these layers of layers of knowledge that's related to how people read visualizations with coming from different backgrounds and coming with different cultural backgrounds. I think I think that's another sort of call for further research in our community to look into these topics. I mean, there was an earlier talk today from John Murdoch from Financial Times on how he sort of acted on the visualization of the pandemic during that months of periods, and he still does that. And there was one discussion on linear versus log scales and how the use of different scales have an impact on how people sort of respond to the visualizations, and even that fundamental question. I think one thing we noticed that we lack the research to be able to respond to that question, to be sort of confidently say, oh yeah, this, like the difference between how people are reading log scale versus linear scale visualization is this. I think that there is, I mean, these are all opening up new research questions that we haven't looked into as a community. That, I mean, I think we are far away from guidelines. I think we just first need to understand these things first with more.
I would be
like
very,
more and more
very
studies on these topics.
I would be very curious to understand, like, for example, at pre-pandemic, I would have said log scales are not something that you ever want to show in a newspaper, right? That was just like way too complicated and people will just like get it wrong. But I wonder now whether this has changed, whether people are now literate and comfortable, at least some, or not, maybe not. But I would be very curious to study, and I suspect that people are now way more comfortable with log scales. And it's just like a phenomenon, right? This exponential growth is a phenomenon that is so easily expressed in a log scale. There isn't really like a good alternative, and it's so useful and so valuable. But yeah, that would be a very interesting study to do.
Another interesting space that comes up, if it's any reassurance in the epidemiology community, there have been debates about how you represent relative risk, and should it be on a log scale or a linear scale? And there's been debates in that space for years in terms of what the more appropriate approach is. And I would hope that our way of understanding it could be through better research about understanding how people interpret and understand the numbers with these different ways of visually representing them. And also thinking too about the language and the use we use. I know, Alex, I think you mentioned the annotation layers and how critical those were to enabling understanding. We've also seen some significant misuse of annotation layers where people will use language that, for example, blames heightened levels of COVID amongst Black Americans on their race, rather than focusing on all the different issues of systemic racism that we face that kind of create those different preconditions for being at higher risk of a disease. And so I think thinking about not just the visual representations, but also how we as visualizers, so focused on the marks and the plots, really think purposefully about those annotation layers and test the language with people from those communities wherever we can to get feedback on how it may be misunderstood or even weaponized is so important. And this pandemic has really brought those ethical challenges, I think, for us to the forefront, that maybe we can't have a comprehensive list of what to do, but perhaps thinking more about what questions we need to ask and how can we be more cautious and careful about what we publish.
Right. So we have a few more minutes, very few, that Tatiana, do you want to say something in this, on this question?
Well, I think there are things that we can also on a technical side do. From the first keynote, we saw that one of those 5 things that we that are for the guidelines is also, for example, the device. I know that there are things that how people really use the visualization, on which device they use it. When we create the visual in this distributed environments, we don't have any impact on how people really use the visualization. But are there ways how we can constrain the use of visualization to those types that are there where it was created for? For example, if we go back to the number of cases, if there were very few infections, a normal bar chart or a line chart would be okay. As the growth was suddenly exponential, one needs to use the logarithmic scale. But this is maybe not what the visualization was done at the time when it was created, because the data was different. So the question is, how do we also adapt those visualizations and guidelines to a stream of updating data, newly coming data? Shall the visualization be adaptable to also those cases? I mean, this is something we also can think about.
I think it sounds very reasonable to reuse what we already know, have already validated. So Amanda said many times this responsibility, right? To be responsible, to be ethical The good thing is that we have done so much research already in visualization. And we can if we could make use of it and sort of like standardize it, that would be a huge step. I think that could solve many of the questions that arise here. We have to sum up because unfortunately this amazing workshop is finalizing. There are many comments from our colleagues. Kennedy said in many copied representations, Kennedy Andrenko, I miss details of data collection. Some countries demonstrate weekly cycles due to missing reporting on weekends. Other countries, for example, France, have different systems with daily reporting from public health and irregular reporting from private. This kind of a contextual background is essential for understanding. And that's also connected with all of the what you have discussed, right? So if we had to sum up this, this panel and also this workshop, I would say also Cagatay wrote afterwards a question about context. Alex talked about context. Sara challenged context. Non-visualizations is context-free. Tatiana changed the context of her tool and applied it to this pandemic. And well, talking about context, obviously, Amanda, she comes from public health, so this is her context. So I think this was a key point all over our workshop, also for teaching. And the other interesting point that everybody mentioned is, okay, we have the guidelines. We need to learn them. We need to be knowledgeable. But then we have to be also to criticize them, to apply our critical thinking to see in which context they can be applied. So I think those are there were many other points that I agree that the audience is very important. I think we all agree, but we can also agree on disagreeing, and this is the key point on understanding, in our opinion, the guidelines that we need to discuss them, and we can agree on disagreeing, or as long as we can situate them into the correct context. So I don't know if my colleagues want to say something. There is 1 minute more. Yeah, so go ahead. Then Alfie, if you want to add something.
Not much to add, I think, from my side. Thanks again, everyone, to the panelists and the keynote speakers, of course. So interesting discussions. It's a bit sad that the workshop got cut in its length and that we all can only meet online. So I hope we can somehow find a way of continuing these discussions offline. Or I was just basically wondering if there's anyone having suggestions or opinions for how to continue these discussions offline or beyond these workshops, and especially in terms of visualization guidelines, if there should be another workshop next year, if how we should structure that other workshop, and if there are any other suggestions of keeping this discussion offline and continuing this discussion offline, basically.
Thanks to organizers.
Yeah, I have
Absolutely.
nothing to add except to thank all the panelists and the keynotes, and then we can continue discussing it on Discord if you have any suggestions. And yeah, hope everybody enjoy this.
Yes. Thank you,
Thank you to
everybody.
the organizers. Thanks.
Thanks, everyone.
Thank you for your work.
Morse complexes have shown a great utility in understanding the topology of complex scientific datasets. The noise in the scalar field, however, can significantly distort the Morse complex topology. Hence, we study the extraction of Morse complexes for ensembles of noisy scalar fields through their uncertainty visualization using our proposed statistical summary maps.
We present a flexible and easy-to-use software infrastructure for interactive rendering of large-scale display walls, either from on-site or from remote cluster. The display servers can easily be configured to support a range of typical network and display hardware configurations. The client library provides a straightforward interface for easy integration into CPU and GPU renderers. We also demonstrate this framework for use in deploying low-cost alternatives for display walls.
CarxS is an authoring system which enables rapid creation of zooming-based scatter plot-like visualizations in just tens of lines of JSON. We contribute a declarative grammar for such visualizations, which captures a large design space. By working with multi-node database spatial indexes, CarxS enables interactive browsing of billions of data points. Come listen to our talk to learn more.
Taylor-Coyer flows is a turbulent fluid motion created in the gap between the two rotating cylinders. The traditional reason-based methods are only able to capture the small-scale coherent structure. The detection of the large structure depends on the 2D cross-section, which is not the true configuration. We adapt the feature-level set methods and the density estimation to combine multiple attributes and use them as the filter to separate large and small-scale structure.
Deep learning models have become ubiquitous, but we often lack interpretations for their decisions. We developed a visual analytics system to interpret models that perform multi-class DGA classification. For each layer of the model, we visualize clusters inside its activation data, showing how classes and clusters relate to each other. In addition, we provide a decision tree to explain how these clusters are constructed.
Progressive visual analytics provides intermediate results in the middle of computation to address a long computational delay. However, such intermediate results are uncertain, so findings from these results can turn out to be incorrect for the entire data. In progressive visual analytics with safeguards, we suggest to risk the uncertainty, but we allow humans to leave safeguards every time they risk the uncertainty.
We present an algorithm for raycasting Hermite spline tubes, which result from letting a sphere trace Hermite splines that define its visual attributes. Since we do not employ tessellation, our method enables smooth curves and transitions of radius and color along the tube. Join us for an in-depth look at the intersection routine that enables raycasting hundreds of thousands of them efficiently in real time, and see what makes them a powerful new tool in the inventory of curve and line data visualization.
Ray tracing techniques can create images of astonishing realism and beauty. In the last years, the performance of those techniques has been increased significantly using dedicated hardware. Who thought that it's also possible to accelerate this? We show how to dramatically accelerate force-directed graph drawing with RT cores, yielding a speed up of 4 to 13x. If you want to know more, please see our talk.
CMed is a visual analytics framework for exploring medical image data annotations acquired from crowdsourcing. CMed can be used to visualize, classify, and filter crowdsourced clinical data based on a number of different metrics such as detection rate, logged events, and clustering of the annotations. CMed provides several interactive linked visualization components to analyze the crowd annotation results for a particular video and the associated workers.
As commonly known, dimensionality reduction techniques and their interpretations are complex, biased, and uncertain. In drug design, this highly complicates the search for similar and new chemical compounds. To overcome this issue, Canva brings comparison of different molecular descriptors and properties into one tool, featuring planar, 3D, and table views for evaluating the trustworthiness of high-dimensional data projection.